Hello there and welcome to Life Beyond Seen, where the oldest questions travel quietly through the dark, like ships that have been at sea so long you almost forget they were ever in port. Tonight, we are following one of those ships, a real one, as it happens. A small wooden 10-gun brig sloop that left an English harbour on a grey December morning and carried inside it, without anyone quite knowing it at the time, the seed of an idea that would eventually change the way every human being understands life itself. That is a large thing to say about a wooden ship 90 feet long, and part of what makes this story worth telling slowly, at night, in the quiet, is that it did not look large from the outside. It looked like a naval survey vessel doing its job. It looked like a young man going on an adventure. It looked, to most people watching from the dock at Plymouth in December of 1831, like something ordinary, a ship departing, another voyage beginning. The kind of thing that happened all the time in a seafaring empire, but some journeys carry more weight inside them than they show on the surface. Some voyages look like one thing and turn out to be something else entirely, and the voyage of HMS Beagle is perhaps the clearest example in all of human history of a journey that appeared, from the outside, to be about maps and coastlines and chronometer readings, and turned out to be about the origin of every living thing on Earth. The man at the centre of this story was 22 years old when he stepped aboard. His name was Charles Darwin. He was not, at that point, the towering figure whose portrait hangs in science classrooms around the world. He was not a genius with a plan. He was not even the ship's official naturalist. He had been invited, in the somewhat informal language of the time, as a gentleman companion to the captain. Someone educated, agreeable, and curious enough to share long dinners in the officer's cabin during the months at sea. That was the role. That was the invitation. And Darwin, after some family drama we'll get to shortly, accepted it. He boarded the Beagle at Plymouth Harbour on December 27th, 1831. The ship had actually been delayed several times by bad weather, and Darwin had been waiting anxiously for weeks in nearby lodgings, writing letters, collecting himself, probably second-guessing everything. When the Beagle finally left port that morning, heading south into the Atlantic, Darwin was on deck watching England disappear behind him. He was 22 years old, prone to seasickness, uncertain of himself, and carrying in his luggage a copy of a geology book that would help him see the world in a way no one had quite seen it before. He had no idea what he was sailing into. None of them did. Before we go any further into that story, I want to pause for just a moment and ask where you are listening from tonight. It is a simple question, but I am genuinely curious. Are you at home, in bed, with the lamp still on? Are you somewhere cold, somewhere warm? Is it late where you are, or just the kind of quiet that feels late even when it isn't? There is something fitting about listening to this particular story at night, because Darwin did a great deal of his thinking in the dark, in a hammock above a chart table, with the ship moving beneath him and the ocean stretching out in every direction. He wrote letters by candlelight. He pressed specimens into paper by whatever light he could find. Some of his best observations came during long, slow hours when there was nothing to do but look and think. If you are finding this kind of quiet storytelling useful, whether for sleep, for thinking, or just for company on a long evening, I would be genuinely grateful if you gave this video a like and subscribe to Life Beyond Seen. It is a small thing, but it helps this channel reach more people who might want to settle in for exactly this kind of slow, careful journey through history and science. And there is a great deal more of this story still to tell, now. Back to the ship. The HMS Beagle was not a grand vessel by any measure. 90 feet long, which is roughly the length of a modest apartment building laid on its side. It carried 10 guns, which classified it as a brig sloop in the Royal Navy's taxonomy of ships. It had been refitted specifically for this voyage, its decks raised slightly to make it more seaworthy, its hull filled with equipment for surveying and measurement. It carried 74 people in a space that would feel cramped to a modern person even with half that number. Darwin's personal cabin was tiny. He slept in a hammock strung above the chart table in the poop cabin, at the stern of the ship, and every morning he had to take his hammock down so the officers could use the table. He shared that space with other men and their equipment, their charts, their instruments, their smell. He was seasick almost immediately, and he would remain on and off seasick for the better part of 5 years. The captain of the Beagle was Robert Fitzroy, who was 26 years old at the time of departure, just 4 years older than Darwin. Fitzroy was brilliant, meticulous, deeply religious, and prone to severe moods that sometimes tipped into what we might now recognise as depression. His uncle, Viscount Castlereagh, had died by suicide, and Fitzroy was aware of that shadow in his family. He had specifically requested a gentleman companion for the voyage, partly for scientific purposes, and partly, one suspects, because he was afraid of being alone with his own mind for 5 years on the open ocean. He wanted someone to talk to at dinner, someone educated enough to be worth arguing with. Darwin and Fitzroy would argue, frequently and sometimes bitterly, but that is getting ahead of things. What matters right now in this opening is the picture of it. December the 27th, 1831, Plymouth Harbour, a grey English morning. A small wooden ship 90 feet long, loaded with instruments and provisions and 74 people. A 22-year-old young man at the rail watching the coastline recede. Not a scientist yet, not an icon, not a name that would one day be known in every corner of the world. Just a young man, curious and a little frightened, sailing away from everything he knew toward a coastline he had never seen. That is where the story begins, not with a theory. Not with a discovery, with a departure. And what makes it worth following so carefully all these years later is not just what Darwin found at the end of the voyage, it is who he was at the beginning of it. Because the theory of evolution by natural selection did not arrive in a flash of inspiration on a remote volcanic island. It arrived slowly over decades, through the accumulation of thousands of small observations made by a young man who had almost not gone at all, who had nearly been refused by his own father, who had nearly been rejected by the captain for the shape of his nose, who had packed his bags and unpacked them and packed them again while the ship sat in Plymouth, waiting for the weather to clear. The voyage behind the theory of evolution is not a story about a genius. It is a story about curiosity, patience, and the slow, sometimes uncomfortable process of looking at the world carefully enough that it eventually tells you something true. And it begins, as so many important things do, not with certainty, but with a young man who simply said yes when the letter arrived. The letter, in this case, came from his mentor at Cambridge, a botanist named John Stevens Henslow, who had been asked to recommend someone for the voyage and had thought of Darwin. Henslow knew Darwin well. He had seen the quality of his mind during their long walks together discussing natural history, and he believed Darwin had something worth developing. The recommendation was not exactly glowing in its confidence. Henslow told Darwin he was not, perhaps, a finished naturalist, but that he was the best qualified person he knew who was likely to be willing to go. Which is the kind of endorsement that is both encouraging and slightly deflating depending on how you read it. Darwin read it as encouraging. He wrote back immediately and said he would be delighted to go. Then his father said no. Robert Darwin, Charles's father, was a wealthy physician in Shrewsbury. He was a practical man, not unsympathetic to his son's interests, but genuinely worried that this voyage was another in a series of enthusiasms that would distract Charles from a real career. Darwin had already abandoned medicine at Edinburgh, which had cost money and time. He was now meant to be preparing for the clergy at Cambridge, which was considered a respectable and stable path. Going to sea for 2 years, which was the original estimate, on a Navy survey ship, seemed to Robert Darwin like the kind of thing a young man did when he was avoiding his actual life. He wrote his son a letter listing his objections. There were 8 of them. It was not conversation. It was a document. Darwin was crushed. He wrote back to Henslow and declined the invitation. Then he went to visit his uncle, Josiah Wedgwood II, of the famous pottery family, and told him the situation. Wedgwood thought the objections were not as serious as Robert Darwin had made them sound, and he wrote a point-by-point response to each one and rode over to speak with his brother-in-law in person. Whatever was said in that conversation, It worked. Robert Darwin changed his mind, and Charles Darwin was given permission to go. Then there was the matter of Fitzroy's nose. Fitzroy was a believer in physiognomy, the now thoroughly discredited idea that a person's character could be read in the shape of their face. He looked at Darwin and had doubts. Specifically, he doubted that a man with Darwin's nose had the energy and determination required for a long and difficult voyage. Darwin, who did not know this at the time, apparently passed some further inspection, because Fitzroy ultimately agreed to take him. Darwin only learned about the nose later, and found it both amusing and a little alarming. He wrote that Fitzroy had afterwards been well satisfied that his nose had spoken falsely. So Darwin went. By a combination of his mentor's recommendation, his uncle's persuasion, his father's eventual generosity, and Fitzroy's decision to overlook his nose, Charles Darwin stepped onto the HMS Beagle and sailed out of Plymouth Harbour on the 27th of December, 1831. He was not the ship's naturalist in any official capacity. He was a passenger, a gentleman, a companion. He paid for his own provisions and his own equipment. He had no salary, no formal role, no institutional backing beyond his own family's money, and the goodwill of a captain who wanted someone interesting to talk to. And yet, in the years that followed, in the notebooks and letters and specimen crates that accumulated across 5 years and 40,000 miles, this uncertain young man would quietly gather the raw material for the most significant idea in the history of biology. But before we can understand what the voyage gave him, we need to understand what he brought to it. Not the theory, not the genius, but the person. The beetle collector from Shrewsbury, the failed medical student, the reluctant clergyman, the young man who once put a beetle in his mouth to free his hands for a better specimen. That is where the story goes next. Charles Darwin was born on the 12th of February 1809 in Shrewsbury, a market town in the English Midlands sitting beside the River Severn. The house he grew up in was large and comfortable, set back from the road behind a garden that sloped down toward the water. It was the kind of house that said, quietly and without fuss, that the family inside it was doing well. His father, Robert Darwin, was a physician of considerable reputation and even more considerable size. He weighed, by some accounts, over 300 pounds and was known for his sharp intelligence, his ability to read people, and his occasional severity with his children's choices. Robert Darwin was not a cruel man. He was a practical one. And practicality, when applied to a son who kept changing direction, could feel very much like pressure. Darwin's mother, Susanna, died when Charles was 8 years old. He remembered very little of her afterward, which troubled him quietly for the rest of his life. He was raised largely by his older sister Caroline, who was diligent and a little strict, and by the general atmosphere of a prosperous household that expected its children to amount to something recognisable. His grandfather, Erasmus Darwin, had died 7 years before Charles was born, but his presence still moved through the family like a current. Erasmus Darwin had been a physician, a poet, and a natural philosopher of some ambition. He had written a book called Zoonomia, published in 1796, which speculated, carefully, speculatively, but genuinely, that all warm-blooded animals might have descended from a single living filament. It was not a worked-out theory. It was more like a question held up to the light. But it was there, in the family library, in the family name, in the intellectual air of the household. Charles Darwin grew up in a family that had already, in a loose and unfinished way, thought about the mutability of life. Whether that mattered or not is hard to say. Ideas in families work slowly, like water through stone. At 16, Darwin was sent to Edinburgh to study medicine, alongside his older brother Erasmus. It did not go well. He found the lectures dull, which was perhaps forgivable. He found the surgical demonstrations unbearable, which was more consequential. Surgery in 1825 was performed without anaesthesia, and Darwin watched 2 operations, one on a child, and left before they were finished and never went back. He did not have the stomach for it, and he knew it. He spent 2 years in Edinburgh doing very little medicine and a great deal of natural history, attending meetings of the Plinian Society, a student natural history club, and spending time with a man named Robert Grant, a zoologist who was already thinking seriously about the transmutation of species. Darwin listened to Grant's ideas with interest. He did not yet know what to do with them. His father, watching the Edinburgh experiment fail, made a decision. Charles would go to Cambridge, study for a degree in theology, and become a clergyman. This was not an unusual path for a young man of his background and abilities. The Church of England offered a comfortable life, some intellectual freedom, and time. Many naturalists of the period were clergymen. It was considered entirely compatible with an interest in natural history, which was itself often seen as a form of appreciating God's creation. Darwin did not object strenuously. He was not at that point a man of strong objections. He was a man of enthusiasms, and he simply redirected his energy toward Cambridge and hoped for the best. He arrived at Christ's College, Cambridge in January 1828 and spent 3 years there. He did not distinguish himself academically in any urgent way. He passed his exams, finished 10th in his class among those who did not pursue honours, and spent a remarkable amount of his time doing something that had nothing to do with theology at all. He collected beetles. This is not a minor detail. The beetle collecting was serious. It was consuming. Darwin pursued it with the kind of focus that, in a different context, might have alarmed people around him. He would spend hours searching under bark in rotting wood, along riverbanks, in the muddy edges of fields. He kept careful records. He corresponded with other collectors. He was known among his peers for it in a way that mixed admiration with mild bewilderment. One story that has followed Darwin ever since, and which he himself recorded, involves a moment when he was pulling bark from a tree and found 2 rare beetles, one in each hand. Before he could secure them, he spotted a 3rd species he had never seen before. With no free hands, he put one of the beetles in his mouth to hold it. The beetle, apparently displeased with this arrangement, discharged some kind of caustic fluid, and Darwin had to spit it out. Losing that one in the process, he was disappointed. The 3rd beetle got away too. But what the story captures is the quality of his attention. He was not casually interested. He was the kind of person who would put a beetle in his mouth. His mentor at Cambridge, the man who would eventually change the course of his life, was John Stevens Henslow. Henslow was a professor of botany, a clergyman himself, deeply respected, and known for his long Friday evening gatherings where students and academics would discuss natural history over tea. Darwin began attending these evenings and quickly became one of Henslow's favourites. Not because Darwin was the most brilliant student Henslow had, but because he was genuinely curious, genuinely attentive, and willing to walk for hours through the Cambridge countryside discussing plants, insects, geology, and whatever else came up. The two became so inseparable that Darwin was sometimes known around Cambridge as the man who walks with Henslow. He found in Henslow something his formal education had not given him, a model of what a serious, careful, curious mind looked like in practice. It was through Henslow that Darwin was introduced to geology, and specifically to the work of Adam Sedgwick, a professor at Cambridge who invited Darwin on a geological field trip to Wales in the summer of 1831. This was only a few months before the Beagle invitation arrived. Darwin spent several weeks in Wales learning how to read rock formations, how to identify strata, how to think about what the landscape was telling him about time. He found he was good at it. He found he enjoyed it. He returned to Shrewsbury in late August 1831 with a new skill and a new way of looking at the ground beneath his feet. And then the letter from Henslow was waiting for him. The letter explained that a survey ship called the HMS Beagle was preparing to depart on a voyage to chart the coastlines of South America, and that the captain, a young man named Robert Fitzroy, wanted a gentleman naturalist to accompany him. Not an official naturalist in the Navy's employ, but a companion. Someone educated, curious, presentable, and willing to spend 2 years at sea. Henslow had been asked first, and had declined because of family obligations. He had then thought of Darwin. Darwin was 22 years old. He had no degree yet. He would receive it in the spring of 1831, technically before the ship departed. He had no formal training as naturalist. He'd collected beetles, attended lectures, walked with Henslow, and spent a few weeks learning geology in Wales. He had read widely, but not deeply, in any single field. He was, in the most honest assessment, enthusiastic and promising, but not yet accomplished. Henslow knew this. His recommendation, as mentioned earlier, was careful. He told the relevant parties that Darwin was not the finished article, but that he was the best qualified person he knew who would actually be willing to go, which, in the world of academic recommendations, is a sentence that does a lot of work while giving very little away. Darwin wanted to go immediately and completely. He wrote back to Henslow within hours. Then his father's objections arrived, and then his uncle Josiah Wedgwood II rode to Shrewsbury and talked Robert Darwin around, and then there was the matter of Fitzroy's nose, which we have already covered. And then Darwin began preparing. He bought instruments. He bought a good microscope, which cost him a significant sum. He bought books, including the first volume of Charles Lyell's Principles of Geology, which Henslow recommended he read on the voyage but not believe too literally. He bought collecting jars and nets and notebooks. He arranged for his specimens to be sent back to Henslow during the voyage, so that the collections would reach England safely even if he did not. This was a practical decision, but it also suggests something about how seriously he was taking the enterprise, even before he had left. He also felt sick with anxiety for much of the preparation period. The Beagle was delayed repeatedly by weather. Darwin travelled down to Plymouth, then went home again, then came back. He had palpitations and what he described as discomfort around his heart, which he attributed to the stress of waiting. He worried he was not fit enough. He worried about leaving his family. He worried in a general and unfocused way that something would go wrong. He was not a man who moved easily through uncertainty, and the weeks before departure were full of it. He was also not, it should be said, particularly experienced with hardship. He had grown up in a large house with servants and a father who, for all his practicality, had given his children a comfortable life. He had been to university. He had eaten well, slept in proper beds, and spent his outdoor time in the English countryside, which is lovely, but not exactly demanding. He had never been to sea for more than a day trip. He had never been anywhere that was genuinely remote or genuinely dangerous. He was about to spend 5 years sailing through the South Atlantic, around Cape Horn, across the Pacific, and through the Indian Ocean on a wooden ship 90 feet long, in conditions that would make his Cambridge rooms look like a palace. He did not fully know this yet, or perhaps he did, and went anyway, which is its own kind of courage. What he brought to the voyage, in the end, was not a set of conclusions or a framework or a theory. He brought a quality of attention. He brought the habit of looking carefully, of recording what he saw, of asking why something was the way it was rather than simply accepting that it was. He brought the beetle collector's instinct, the sense that the specific detail matters, that the small thing in front of you is worth examining closely before you move on to the large ideas. He brought Henslow's example of patient, methodical inquiry. He brought Sedgwick's geological eye, the ability to look at a landscape and ask what it was telling him about time. And he brought something harder to name, a genuine openness to being surprised, a willingness to let the world correct his assumptions rather than arranging his observations to fit what he already believed. None of this was a theory. None of it was even close to a theory. He was a young man with a good education, some useful skills, and an enormous capacity for curiosity. That was what got on the ship. The theory would take another 27 years to arrive in print, by a long and winding route that neither Darwin nor anyone else could have mapped in advance. But there is something worth sitting with for a moment before we move on. The almost accidental nature of Darwin's presence on the Beagle is not a charming footnote. It is actually central to the story. Because the theory of evolution by natural selection was not the result of a planned scientific expedition. It was not the product of an institution that set out to answer the question of how species change. It was the result of a young man who went on a voyage for no very precise reason, collected things carefully, thought about them for a long time, and eventually arrived at an idea that changed everything. The institutions, the plans, the official purposes of the voyage, all of those were pointing in a completely different direction. The Royal Navy wanted charts. Fitzroy wanted a companion. Darwin wanted to see the world. What emerged from that combination was something none of them had asked for and none of them had predicted. That is not how we usually imagine great scientific discoveries. We tend to imagine intention, focus, a clear question, and a methodical search for the answer. Darwin's story is not like that. It is messier, more contingent, more dependent on chance than we might prefer. And that, in its own way, is one of the most interesting things about it. The ship he was about to spend 5 years on was not designed for his comfort or his research. It was a Royal Navy survey vessel with a specific mission, a specific captain, and a specific set of priorities that had nothing to do with natural history. Understanding what that ship was, what it was actually trying to accomplish, and who was in command of it, tells us a great deal about the conditions under which Darwin made his observations. And the captain, Robert Fitzroy, is a figure complicated enough to deserve careful attention, because the relationship between these two men, one who would spend the rest of his life building a theory that contradicted the Bible, and one who would spend the rest of his life defending it, shaped every mile of the voyage in ways that are still worth tracing. The HMS Beagle was not a glamorous ship. It was not built for exploration in the romantic sense, not designed to carry scientists or philosophers or men with grand ideas about the nature of life. It was a Royal Navy brig sloop, a working vessel, practical and functional, built for survey work and coastal measurement. 90 feet long, roughly 24 feet wide, with 10 guns it almost never needed to fire. It had been launched in 1820 at the Woolwich Dockyard on the Thames, and by the time Darwin stepped aboard in late 1831 it had already completed one survey voyage to South America, a voyage that had ended in tragedy and exhaustion and the suicide of its previous captain. That history was not discussed openly, but it was there. The ship had been refitted for this second voyage, raised by 8 inches to give more headroom below decks, which sounds like a small improvement until you consider that the men living on it would spend 5 years in those spaces. Darwin's own quarters were in the poop cabin at the stern, a small room he shared with the ship's surveying instruments and 2 other men. He slept in a hammock strung above the chart table. His writing space was the table itself, which he used when the charts were not spread across it. He described the cabin as not uncomfortable, which is the kind of thing you say when you are trying to be cheerful about a space that is, by any reasonable measure, very uncomfortable indeed. 74 people sailed on the Beagle. Officers, midshipmen, sailors, a surgeon, an instrument maker, an artist named Augustus Earle, who would later be replaced by Conrad Martins, and 3 Fijian passengers returning to their homeland. Darwin was not listed as the ship's naturalist in any official capacity. He was there as a gentleman companion to the captain, a social equal who could share Fitzroy's table and provide the kind of educated conversation that a long voyage demanded. The naturalist role was something he took on by inclination and energy, not by appointment. He paid his own expenses, he supplied his own equipment. He was, in a sense, a self-funded passenger who happened to collect everything he could get his hands on. The official purpose of the voyage was hydrographic survey. The Royal Navy needed accurate charts of the South American coastlines, particularly around Patagonia and Tierra del Fuego, where the waters were poorly mapped and the risks to shipping were significant. The Beagle was also tasked with establishing a chain of chronometric measurements around the world, using a set of carefully calibrated marine chronometers to determine longitude at various fixed points. This was precision work, methodical and unglamorous, and it was the real reason the ship was going where it was going. Darwin's natural history collecting was, from the Navy's perspective, a personal hobby conducted in the margins of the actual mission. Robert Fitzroy was 26 years old when the Beagle departed. He was 4 years older than Darwin, and in almost every outward respect he seemed the more complete and impressive figure. He was a brilliant navigator, meticulous and technically gifted, descended from King Charles II and deeply proud of his lineage. He had taken command of the Beagle during the first voyage when the previous captain, Pringle Stokes, had shot himself in his cabin after months of psychological deterioration in the brutal waters around Cape Horn. Fitzroy had brought the ship home safely, had handled the crisis with composure, and had been given command of the second voyage as a result. He was, by any measure, an extraordinary officer. He was also a man who carried a particular weight. His uncle, Viscount Castlereagh, had died by suicide in 1822, and Fitzroy was acutely aware that a tendency towards severe depression ran in his family. He had requested a companion for the voyage partly because he feared the isolation of command, the long stretches of solitary responsibility in remote waters that had broken his predecessor. He wanted someone educated enough to be worth talking to, someone who would share his table and his evenings, someone who could push back in a conversation rather than simply agree. Darwin, recommended through the Cambridge network and vetted by Henslow, seemed to fit that need. What Fitzroy had not entirely anticipated was how different their views would turn out to be on certain subjects. Darwin opposed slavery without reservation. He had grown up in a family with strong abolitionist sympathies. His grandfather Erasmus had written against it, and the Wedgwood family, into which Darwin was connected through his uncle and would later marry, held the same position. Fitzroy, by contrast, believed that slavery was defensible under certain conditions, and he had encountered enslaved people during his earlier travels who had, in his view, expressed contentment with their situation. He told Darwin this during one of their dinners. Darwin replied with some heat that asking an enslaved person whether they were content in front of their enslaver was not a meaningful test of anything. Fitzroy found this insolent. He told Darwin that if their views were so incompatible, Darwin could no longer share his cabin. Darwin began making arrangements to eat with the ship's officers instead. By the next morning, Fitzroy had apologised. The incident passed, but the tension it revealed never fully disappeared. This is worth dwelling on, not because the argument was dramatic in itself, but because it tells us something about the texture of the voyage. These two men, confined together on a 90-foot ship for nearly 5 years, were fundamentally different in temperament, belief, and disposition. Fitzroy was deeply religious, precise, hierarchical, and increasingly convinced as the years passed that the natural world was the direct expression of divine creation. Darwin was curious, empirical, open-ended, and quietly moving, though he did not yet know it, toward a view of the world that would eventually contradict everything Fitzroy believed. They argued. They reconciled. They argued again. They shared meals and observations and long evenings in the poop cabin. They maintained a genuine mutual respect, even as the gap between them widened. There were also the 3 Fuegians aboard. Jemmy Button, York Minster and Fuegia Basket were not their real names. They were names given to them by Fitzroy during the first voyage, when he had taken them from Tierra del Fuego and brought them to England. Jemmy Button was so named because he had been acquired, the word is uncomfortable but accurate, in exchange for a pearl button. York Minster was named after the famous cathedral, apparently because Fitzroy thought the rock formation near where he was found resembled it. Fuegia Basket was a young girl. All 3 had spent time in England, had been presented at court, had learned English, had worn English clothes and eaten English food and attended church. Fitzroy's intention in returning them was to establish a Christian mission in Tierra del Fuego, to use them as a bridge between European civilization and the people they had come from. He had genuine conviction about this project. It was not cynical. He believed sincerely that he was doing something beneficial. Darwin observed all of this with a mixture of fascination and unease. He had never encountered people so different from himself, and the presence of the 3 Fuegians on the ship, people who existed between 2 worlds, belonging fully to neither, raised questions in him that he did not yet have the language to address. What did it mean that the same person could live in such different ways depending on where they were? What did it mean that Jemmy Button, who had worn tailored English clothes and conversed politely in English drawing rooms, would return to Tierra del Fuego and within months be living exactly as his people had always lived, wearing almost nothing, eating raw shellfish, moving through one of the most inhospitable landscapes on Earth with complete ease? Darwin found this deeply significant, though he was not sure yet what it was significant of. The Beagle also carried, in addition to its human complement, an enormous quantity of scientific instruments. 22 chronometers, carefully maintained and checked against one another throughout the voyage. Barometers, thermometers, a dipping needle for measuring magnetic variation, sounding equipment, drawing instruments, and the standard tools of hydrographic survey. Fitzroy was meticulous about all of it. He kept detailed meteorological records throughout the voyage, and would later, after returning to England, become one of the founders of what we now call weather forecasting, establishing the first system of storm warnings for British coastal shipping. He was not simply a naval officer, he was a serious scientist in his own right, and his commitment to precise measurement and careful record-keeping set a standard that influenced Darwin as well. Darwin had brought his own equipment, collecting jars, nets, a geological hammer, notebooks, a copy of Alexander von Humboldt's personal narrative of travels, and the first volume of Charles Lyell's Principles of Geology, which Fitzroy had given him as a gift before departure. Henslow had recommended Lyell's book, but had also warned Darwin not to believe it too readily, which is a very academic way of saying that Lyell's ideas about gradual geological change over vast spans of time were still controversial. Darwin read it carefully, with the particular attention of someone who is about to see the landscapes the book describes. The Beagle's planned route would take it south along the Atlantic coast of South America, around Cape Horn, up the Pacific coast, across to the Galapagos, then west across the Pacific to Australia, through the Indian Ocean, around the Cape of Good Hope, and back to England. The whole voyage was estimated to take 2 years. It took nearly 5. Fitzroy's determination to get the survey work right meant repeated returns to the same coastlines, extended stays in difficult anchorages, and a level of thoroughness that was professionally admirable and personally exhausting for everyone aboard. Darwin, who had expected 2 years, found himself still at sea in his 4th year with no clear end in sight, writing letters home that grew increasingly wistful about English food, English countryside, and English beds. But all of that was still ahead. In the last days of December 1831, the ship was preparing to leave Plymouth. Darwin was 22 years old, nervous, excited, and not yet seasick. The chronometers were wound, the charts were stowed, the provisions were loaded. Fitzroy was satisfied, or as close to satisfied as Fitzroy ever got, that everything was in order. The 3 Fuegians were aboard, quiet and watchful. The crew was ready. The weather, which had delayed the departure twice already, was finally cooperating. What none of them knew, standing on that deck in Plymouth Harbour in the last week of 1831, was what the voyage would actually produce. Fitzroy believed it would produce better charts and a Christian mission in Tierra del Fuego. The Admiralty believed it would produce chronometric data and improve navigational records. Darwin believed it would produce a collection of natural history specimens and, if he was lucky, the kind of direct experience of the natural world that he had read about in Humboldt and longed for since his first years at Cambridge. All of those things happened, but something else happened too, something that none of them had planned for and none of them could have predicted. The voyage would produce a way of seeing. A particular quality of attention applied to the natural world across 5 years and tens of thousands of miles, an attention that would eventually, slowly over decades of further thought and reading and correspondence, produce the idea that changed how human beings understand themselves and every other living thing on Earth. But that was a long way off. First, there was the sea, and the sea, as Darwin was about to discover, had its own very immediate and very unpleasant way of introducing itself to people who had never properly met it before. The sea introduced itself to Darwin almost immediately, and it was not a gentle introduction. Within hours of leaving Plymouth on December 27th, 1831, the Beagle hit rough water in the Bay of Biscay. The ship was small, 90 feet of wooden rope, and the Atlantic in winter does not particularly care about the ambitions of the people inside any given vessel. Darwin was violently, wretchedly seasick. Not the mild, uncomfortable kind that passes after a day or two, the kind that made him lie flat in his hammock above the chart table in the poop cabin, unable to eat, unable to read, barely able to think. He described it in his diary as a most miserable state. In letters home he was more direct. He told his family that he had suffered more than he had ever thought possible. The hammock itself was a problem. Darwin was tall, just over 6 feet, and the space above the chart table was not designed for comfort. He had to remove a drawer from the chart table just to have room to stretch his legs out fully. The ship moved constantly, pitching and rolling, the timbers creaking, the air below decks thick and close. He ate almost nothing for days at a time. He lost weight. He lay there and wondered, not for the last time, whether this had been a mistake. The Beagle made a brief stop at Madeira, but conditions prevented a proper landing. Then the Canary Islands, specifically Tenerife, which Darwin had been looking forward to with real excitement. He had read about Tenerife in Humboldt's travels, and had dreamed of seeing the great volcanic peak of Mount Teide, the dragon trees, the lush subtropical vegetation. He had talked about it with his friend and mentor Henslow before departing. But when the Beagle arrived at Tenerife in early January 1832, the port authorities refused to allow anyone ashore. There had been a report of cholera in England, and the Canary Islands were enforcing a strict quarantine. Any ship from Britain would have to wait 12 days before landing was permitted. Fitzroy decided the survey schedule could not accommodate 12 days of waiting, and the Beagle sailed on. Darwin stood on deck and watched Tenerife recede. He could see the peak of Teide through the haze. He wrote that he could not help being a little grieved. It was a small heartbreak, but it was the first of many small adjustments to the gap between expectation and reality that the voyage would require of him. The first real landfall came at the Cape Verde Islands, specifically the island of Santiago, now called Santiago, in mid-January 1832. And here, despite the lingering seasickness, something shifted. Darwin went ashore and found a landscape unlike anything he had encountered in England. Volcanic rock, sparse dry vegetation, the particular quality of equatorial light. He wandered the island with his geological hammer and his collecting jars, and he noticed something in the cliffs near the shore that lodged in his mind and would not let go. Running horizontally through the dark volcanic rock, roughly 45 feet above the current sea level, was a distinct white band. Embedded in it were shells, marine shells, the kind produced by creatures that live in the ocean, along with fragments of coral. The band was clearly an old seafloor, compressed and solidified into rock, and it was sitting 45 feet above the water. Darwin had been reading Lyell on the Voyage. The first volume of Principles of Geology had come aboard as a gift from Fitzroy, and Darwin had been working through it during the days when he was well enough to read. Lyell's central argument was that the Earth was shaped not by sudden catastrophes, but by the same slow processes that were still operating in the present: erosion, deposition, volcanic activity, gradual uplift, working over immense spans of time. The idea was not entirely new, but Lyell had assembled the evidence for it with unusual care and clarity, and his book was both a scientific argument and, in its way, a kind of quiet revolution in how people thought about the age and nature of the Earth. Standing in front of that white band of shells in the cliff face at Santiago, Darwin felt Lyell's argument become something concrete. The land had risen. The seafloor had become a cliff. This had not happened quickly. It had happened slowly, over time, through processes that were still happening. He wrote about it in his diary with a kind of contained excitement that would become characteristic of him. careful, specific, trying to understand rather than simply to marvel. He later wrote that the geology of this island made a deep impression on him, and that he felt he was approaching the study of natural history in a new spirit, not as a collector of curiosities, but as someone trying to understand the processes behind what he was seeing. Lyell had given him a framework. Santiago had given him the first experience of that framework made visible in stone. The Beagle crossed the equator in mid-February 1832. This involved the traditional naval ceremony known as crossing the line, a ritual that had been performed on ships for centuries whenever they crossed the equator for the first time with new crew members aboard. The ceremony involved Neptune, or rather a sailor dressed as Neptune, presiding over the mock trial and initiation of those crossing the equator for the first time. Darwin was subjected to it along with the other first-timers. It involved being shaved with a rough blade, dunked in a sail filled with seawater, and generally subjected to the enthusiastic attentions of the older sailors. Darwin described it as disagreeable, but took it in reasonable humour. He was, after all, still alive, which was more than could be said for his dignity. The first landing in South America came at Salvador, in the Bahia province of Brazil, in late February 1832, and this was the moment the seasickness and the disappointment of Tenerife and the discomfort of the crossing began to feel, if not exactly worth it, then at least understandable as the price of admission. Darwin went ashore and walked into the tropical rainforest for the first time in his life. He was not prepared for it. Nothing in England, nothing in his reading, nothing in Humboldt's careful descriptions had fully conveyed what it was actually like to stand inside a tropical forest. The density of it, the layering, the noise, insects, birds, things moving in the canopy that he could hear but not see. The scale of the trees, the variety of the plants, the sense of being surrounded by living things in quantities and varieties that his English-trained mind had no framework for. He wrote in his diary that the day had been one of the most memorable in his life. He described the forest as a cathedral, a word he used deliberately, not casually. He meant that the experience had a quality of awe that he associated with the finest human architecture, but that this was not made by human hands, and its scale made any cathedral he had ever entered feel modest by comparison. The tangle of lianas, the enormous buttressed roots, the mosses and ferns and flowers growing from every available surface. He wrote that he could not imagine anyone who was not a botanist being able to name a tenth of the plants around them. He was giddy with it. He wrote home saying that he'd been in a transport of delight, and that nothing he had seen or read had given him any idea of what it would be like. He collected everything he could reach: beetles, plants, marine invertebrates from the rock pools along the shore. He sent a long, detailed letter to Henslow describing his first impressions, and that letter, when it eventually arrived in Cambridge, caused something of a sensation among the small circle of naturalists who read it. Henslow showed it to colleagues. They were impressed. The young man they had sent away as a gentleman companion was clearly paying close attention. The seasickness, it should be said, did not go away. Darwin suffered from it throughout the entire voyage. Not every day, but reliably whenever the sea was rough, which in the Atlantic and later the Pacific was often. He developed strategies for managing it. He stayed on deck as much as possible in rough weather, finding that fresh air helped. He ate dry biscuits when he could manage nothing else. He worked when he was able and lay still when he was not. The pattern of the voyage for Darwin was one of intense physical activity and observation during time ashore, followed by days or sometimes weeks of misery at sea, during which he read, took notes on what he had already seen, and waited for the ship to stop moving. It is worth pausing on this for a moment, because it says something about the nature of the whole enterprise. Darwin was not comfortable. He was not in his element. He was a young man who loved riding horses and collecting beetles and eating good food and sleeping in a proper bed, and he had committed himself to 5 years on a 90-foot ship in conditions that made him physically ill for a significant portion of every week. He kept going because the time ashore was extraordinary enough to make the time at sea bearable. Just. Back in Bahia, and then later during the Beagle's extended time along the Brazilian coast, Darwin began to fall into the rhythm that would define his work for the rest of the voyage. He would go ashore whenever possible, sometimes for days at a time, sometimes for weeks, while the Beagle continued its survey work up and down the coast. He hired local guides, bought horses, walked into the interior, collected specimens, made notes, and shipped boxes of material back to Henslow in Cambridge. The boxes arrived in Cambridge over the course of years, accumulating in Henslow's rooms, and the letters that accompanied them were read and discussed and passed around with growing excitement. Darwin collected with the same obsessive energy he had brought to beetle hunting at Cambridge, but now applied to an entire tropical continent. He was not yet thinking about evolution. He was not yet formulating theories. He was doing what he had always done, looking carefully, collecting thoroughly, and asking what he was actually seeing. The theory would come later. What the early months of the voyage were producing was something harder to name: a quality of attention, a habit of noticing, a refusal to accept the world as simply given without asking how it had come to be the way it was. The Cape Verde Islands had given him a cliff with shells in it. Brazil was giving him something else, a landscape so dense with life, so various, so layered, that the sheer fact of it raised a question he could not yet quite articulate. How did all of this come to be here? Why was there so much of it? Why did each new valley seem to contain species that the previous valley did not? He did not have answers, but the questions were forming. He also noticed with the geological eye that Lyell had helped him develop that the landscape itself had a history. The rock formations along the Brazilian coast, the way the land was shaped, the presence of river terraces and ancient beach deposits, all of it suggested a long sequence of change. The land was not static. It had been doing things over a very long time before any human had been there to observe it. The Beagle continued south along the coast. More stops, more collections, more days of seasickness at sea and days of intense observation ashore. Darwin was getting stronger in the field, more confident in his collecting, more systematic in his note-taking. He was also getting better at the physical demands of the work, riding long distances, sleeping rough, eating whatever was available. The comfortable young man from Shrewsbury was becoming, gradually and not entirely painlessly, a working naturalist. The Atlantic crossing and the first months along the South American coast had given Darwin his first geological puzzle, his first tropical forest, and his first real sense of what the voyage was going to demand of him. They had also given him something subtler, the beginning of a habit of mind that would carry him through the next 4 years and eventually through the decades of thought and work that followed. The habit of looking at the world and asking not just what it was, but how it had come to be that way. He did not know yet what he was building. Neither did anyone else. But the raw material was beginning to accumulate. One cliff face and one forest, and one box of specimens at a time. The Beagle was heading south, toward the Pampas, toward Patagonia, toward the cold and the wind and the fossils that were waiting in the cliffs along the Argentine coast. And those fossils, when Darwin finally reached them, would ask him a question that the tropical rainforest had not quite managed to put into words. The Beagle reached the Rio de la Plata estuary in late July 1832, and from there Darwin began the long, slow acquaintance with the Argentine coast that would occupy much of the following year. He had already sent several boxes of specimens back to Henslow. More were coming. The pace of his collecting had not slowed. If anything, it had increased because the variety of the South American interior was even more extraordinary than the coast had suggested. But it was during the months around Rio de Janeiro, from April through July of that year, that Darwin's time in Brazil reached its fullest intensity, both in terms of what he found in the natural world and in terms of what he encountered in the human one. Rio de Janeiro in 1832 was a city built on the labour of enslaved people. Brazil was at that time the largest slave importing country in the world, and the trade was still actively running. Darwin arrived in a place where slavery was not a distant political abstraction. or something he had only read about in pamphlets. It was present everywhere he looked, in the streets, in the houses, in the fields, in the faces of people who were being treated as property in the most literal and brutal sense of the word. He witnessed things that he could not set aside. He saw enslaved men and women being beaten. He saw families separated at auction. He recorded in his diary with a controlled fury that is striking to read even now, the account of a man who threatened to harm his own children rather than allow them to be taken from him. Darwin found the entire institution morally unbearable, and he said so. In his diary, in his letters home, in his conversations on the ship. He had grown up in a family with strong anti-slavery views. His grandfather, Erasmus Darwin, had written against it. His uncle Josiah Wedgwood, the same uncle who had helped convince his father to fund the voyage, came from a family that had actively supported the abolition movement in Britain. Darwin's opposition to slavery was not a performance. It was deep and sincere, and it made him genuinely angry in a way that very little else did. This put him in direct and serious conflict with Captain Fitzroy. Fitzroy was not a cruel man by the standards of his time, but he held views about slavery that Darwin found not only wrong but absurd. Fitzroy had visited a plantation during one of their stops, and reported that the enslaved people there seemed content, that he had asked them directly whether they wished to be free, and they had said no. Darwin pointed out with some sharpness that asking an enslaved person whether they wished to be free while their enslaver stood nearby was not exactly a reliable method of gathering honest answers. Fitzroy did not take this well. The argument escalated. Fitzroy, who was prone to sudden intense rages that passed almost as quickly as they came, told Darwin that he could no longer share his table, that if Darwin found his view so offensive, he was welcome to find other arrangements. The standoff lasted only a few hours before Fitzroy apologised. The two men resumed their shared dinners, and their complicated relationship continued more or less as before. But the episode is worth pausing on, because it reveals something important about Darwin that is easy to lose sight of when you're focused on the theory that came later. He was not a passive observer of the world. He had strong moral convictions, and he was willing to defend them even when it made his daily life uncomfortable. He was living in close quarters with a man who had authority over every aspect of the voyage, and he still said what he thought. That takes a certain kind of character. The argument with Fitzroy did not slow Darwin's work. If anything, the weeks around Rio de Janeiro were among his most productive of the entire voyage. He made multiple inland excursions, sometimes travelling on horseback, sometimes on foot with local guides, pushing into the interior of the country for days at a time while the Beagle continued its survey work along the coast. He collected beetles, moths, marine invertebrates, birds, plants, and anything else he could get his hands on. He described the Brazilian rainforest in his diary with a kind of language he rarely used for anything else, language that is almost devotional in its intensity. He wrote about the cathedral quality of the forest interior, the way the light came down through the canopy in long filtered shafts, the density of the undergrowth, the noise especially. Darwin was struck by the sheer volume of life in the tropical forest, the insects, the birds, the frogs, the constant layered sound of things living and dying and eating and calling. He had grown up in the English countryside, which has its own quiet beauty, but nothing in England had prepared him for this. He wrote that a person could spend a lifetime in a single acre of Brazilian forest and still not have seen everything living there. That was not quite a scientific observation. It was something closer to wonder. He was also, even in the midst of this wonder, working with careful, systematic attention. He collected and labelled everything. He kept detailed notes on where each specimen was found, what it was eating, what was eating it, what other species it lived alongside. He packed specimens in spirits of wine, dried skins, pressed plants and pinned insects, and he shipped them back to Henslow in regular consignments. The boxes were accumulating in Cambridge at a rate that was beginning to draw real attention. Henslow was reading the letters that came with them aloud to the Cambridge Philosophical Society. The specimens were being examined and discussed. Darwin, still at sea and still occasionally seasick, had no idea that the material he was sending home was already being taken seriously by people whose opinion mattered. And then, in September 1832, the Beagle moved south toward Bahia Blanca on the Argentine coast, and Darwin found something that would sit in his mind for years. At a place called Punta Alta, in a low cliff of soft reddish rock near the shore, Darwin noticed bones. Large bones. Bones embedded in the rock face at a level that suggested they had been there for a very long time. He began to dig. What he found was extraordinary. The fossilized skull of a megatherium, a giant ground sloth, along with other large bones that he could not immediately identify. The megatherium was not entirely unknown to science at that point. A partial skeleton had been found in Argentina in the late 18th century and sent to Madrid. But Darwin had never expected to find one himself, lying in a cliff on a beach in Argentina. He extracted the bones carefully, packed them, and added them to the growing cargo of specimens heading back to England. But it was not just the size of the creature that struck him. It was the relationship between what he had found and what was alive around him. The giant ground sloth, he noticed, was not entirely unlike a modern sloth. The proportions were different, the scale was vastly different, but there was a resemblance, a family resemblance, the kind of similarity you see between a great-grandparent's portrait and a living face. The bones were from an extinct creature, clearly, but they were the bones of something that seemed to belong to the same part of the world as the living animals around him, not to Europe, not to Africa, to here, to South America. This was a question, though Darwin did not yet know quite how to ask it. Why would an extinct animal from this region look like a living animal from this region? If species had each been separately created and placed in their proper locations, that was perhaps not surprising. Of course, South American species would be found in South America. But the more he thought about it, the less satisfying that answer felt. The giant sloth was not just from South America. It seemed to be, in some deep structural sense, related to the small sloths hanging in the trees above him. Related across time, not just across space. He would find more fossils as the voyage continued south. A glyptodon, which was essentially a car-sized armadillo, its shell made of interlocking bony plates. A macrauchenia, a strange long-necked creature that resembled no living animal cleanly, but seemed to share features with camels and horses and tapirs, all of which were South American forms. A toxodon, which Darwin described as one of the strangest animals he'd ever seen, combining features of several different living groups in ways that made it difficult to classify. Each of these creatures was enormous, extinct, and distinctly South American in character. Each of them raised the same quiet question. Why did the extinct animals of South America look like the living animals of South America, only larger and stranger? What was the connection? He did not have an answer. He packed the bones and kept moving. Through all of this, the fossils, the collecting, the arguments with Fitzroy, the long days in the rainforest, Darwin was also writing. He wrote constantly. His diary was detailed and vivid and ran to thousands of words. His letters to Henslow were long and careful and full of precise observation. He was not just accumulating specimens, he was accumulating a way of seeing, a habit of looking at the natural world and asking not just what it was but how it had gotten there, what it was doing, what it was connected to, what its presence in this particular place at this particular time actually meant. The moral weight of what he had seen in Brazil stayed with him too. He would write about slavery again and again throughout the voyage and in the years that followed. It was not a passing concern. The experience of seeing human beings treated as objects, of watching families destroyed for profit, of hearing Fitzroy's breezy defence of the whole arrangement, had sharpened something in Darwin's thinking about what it meant to be a person, what it meant to be an animal, what the difference between the two actually was. These were not separate questions from the ones he was asking about fossils and species. They were, In some way, he could not yet fully articulate the same question from different angles. What are we, and how did we come to be this way, and what does that mean for how we treat each other? He was 23 years old. He had been at sea for less than a year. He had already seen more of the world than most people in England would see in a lifetime, and he had found it both more wonderful and more terrible than he had expected. The Beagle was heading further south. The Argentine coast gave way to the Pampas, and the Pampas gave way to the colder, windier, more desolate stretches of Patagonia. Darwin would ride with gauchos across the open grassland, sleep under the southern stars, eat armadillo roasted in its own shell over a fire, and continue to find fossils in the cliffs along the coast. The questions accumulating in him were not yet a theory. They were not even quite a hypothesis. They were a set of observations that did not fit comfortably together, a collection of puzzles that kept pointing in the same general direction without quite resolving into a clear picture. But the direction was becoming visible, slowly, the way a landscape becomes visible at dawn. Not all at once, not in a flash, but gradually, as the light increases and the shapes begin to separate themselves from the dark. The giant fossils and the living animals, the shells in the cliff above the sea. The variety of the rainforest and the question of how so much variety could exist in one place. These were pieces of something. Darwin did not yet know what. But he was keeping them, carefully in his notebooks and his specimen boxes, and in the growing archive of his attention. And ahead of him, still months away, still beyond the cold tip of the continent and the wild waters of Tierra del Fuego, lay the Andes and the earthquake, and eventually a small volcanic archipelago in the Pacific that would give his questions a shape they had not yet found. The Beagle moved south through late 1832, and the coastline of Argentina slowly changed character around it. The flat, fertile grasslands of the Pampas gave way to something wider and emptier. Patagonia, which is not so much a landscape as a condition. The wind there is constant and horizontal, and carries a kind of indifference that is hard to describe. The grass is low and tough. The sky is enormous. The distances between things are long enough to make a person feel small in a way that is not unpleasant exactly, but is not comfortable either. Darwin rode through it on horseback with gauchos, the skilled weathered horsemen of the Argentine plains, and he found the experience genuinely exciting in a way that the ship never quite was. He was not seasick on a horse. He could stop and dig when he wanted to. He could look at things. He ate armadillo roasted in its own shell over an open fire and described it as tasting not unlike duck. He slept under the open sky. He watched rheas, the large flightless birds of South America, related distantly to ostriches, running across the grassland in groups, and he noticed that there seemed to be two kinds, a larger, more common species he was already familiar with, and a smaller, rarer one that the gauchos called the avestruz patis. Darwin had actually eaten most of a specimen of this smaller rhea before realizing it was potentially a different species. He salvaged what remained and sent it back to England, where it was later confirmed as a distinct species and named Rhea darwini in his honour. It is a small story, but it is a very Darwin story. The discovery made half by accident, the specimen rescued from a dinner plate, the careful record kept anyway. The fossils continued. At various points along the Patagonian coast, Darwin found bones embedded in the cliffs, more glyptodon fragments, more fragments of the strange creatures he had begun to catalogue. The glyptodon in particular stayed with him. Its shell was made of hundreds of interlocking bony hexagonal plates, each one fitted precisely against the next, the whole structure forming an armour that covered the animal like a dome. Living armadillos have a similar arrangement, smaller, more flexible, but structurally recognisable as the same basic design. The similarity was too specific to be coincidence, and yet the glyptodon was not just a large armadillo. It was a different creature, extinct, enormous, belonging to a world that no longer existed, and yet it had lived here, in South America, in the same region where small armadillos still live today. The pattern kept repeating itself. Extinct South American giants, living South American animals, the same region, the same structural resemblances, no clear explanation for why this should be so if each species had been independently created and placed exactly where it belonged. Darwin did not write these thoughts down as conclusions. He wrote them as questions, observations, things worth noting. His notebooks from this period are full of careful descriptions and occasional puzzled asides. Phrases like, "This appears to me most singular," or "I am quite puzzled by this." He was not yet theorizing, he was accumulating. But the accumulation was building towards something, even if he could not yet see its shape. In December 1832, the Beagle reached Tierra del Fuego, and the world changed again, in temperature, in landscape, and in something harder to name. Tierra del Fuego is the archipelago at the southern tip of South America, separated from the mainland by the Strait of Magellan. The name means land of fire, given by Magellan's expedition 3 centuries earlier because of the fires the indigenous people kept burning along the shore. The landscape is dramatic in a cold, compressed way. Glaciers coming down to the water's edge, dense, temperate rainforest clinging to steep hillsides, channels of dark water threading between islands, and weather that can shift from bright and clear to violent and wet within the space of an hour. The winds in the Drake Passage just to the south are among the strongest on Earth. Even in the sheltered channels, the conditions are difficult. The light in summer is long and strange, and in winter the darkness is deep. Darwin was struck by the place immediately. He described the scenery as wild, gloomy, and magnificent. The glaciers blue-white against the dark forest, the mountains sharp and snow-covered, the water reflecting everything back in cold colours. It was beautiful in the way that extreme places often are, a beauty that does not invite you to relax into it, but rather demands that you pay attention. But it was the people who affected him most. The indigenous Fijians, the Yagan, the Kaueskar, and other groups, had lived in this environment for thousands of years. They were adapted to it in ways that astonished Darwin. They wore little or no clothing even in cold and wet conditions, their bodies accustomed to temperatures that would have been dangerous to a European. They moved through the channels in canoes, fishing, hunting sea mammals, living in small family groups with a material culture that was, by European standards of the time, extremely simple. Darwin's first reaction was the unexamined one of his era. He described them as among the most abject and miserable creatures he had ever seen, and his initial comparison was unfavourable. He was a young man of his time, and his time had particular ideas about civilization and its relationship to material complexity. But what complicated this reaction immediately was the presence of Fitzroy's 3 Fijians on the ship. Jemmy Button, York Minster, and Phrygia Basket had been taken to England 4 years earlier during Fitzroy's previous voyage. Jemmy Button's family had received a mother-of-pearl button as a kind of informal exchange, which is where his English name came from. They had spent time in England, learned English, been presented to King William IV and Queen Adelaide, worn English clothes, eaten English food, attended English church services, and generally been treated as a kind of experiment in whether indigenous people could be civilized by exposure to European culture. Fitzroy believed they could be, and he was bringing them back to Tierra del Fuego with a missionary named Richard Matthews, with the intention of establishing a Christian mission among their people. Darwin watched all of this with genuine interest and some quiet scepticism. He liked Jemmy Button. Most people on the ship did. Jemmy was sociable, good-humoured, proud of his appearance, and had adapted to English life with apparent ease. He was particular about his hair and his shoes. He was distressed when he saw his own reflection and found himself looking untidy. He had a personality that came through clearly, and Darwin spent time talking with him. York Minster was older and more reserved, less easily read. Phrygia Basket was young, quick, and had picked up languages with remarkable speed. The mission attempt failed almost immediately. Within days of being settled ashore with Matthews and a collection of English goods, tools, crockery, linens, tea trays, the local Fuegians had taken most of the supplies. Matthews was frightened and had to be rescued. The settlement was abandoned. When the Beagle returned to the area a few weeks later, Jemmy Button appeared in a canoe to meet them. He was thin, his hair long, his English clothes gone, dressed as his people dressed. He had a young wife. He seemed, by his own account, content. He said he had no wish to return to England. He said he had plenty to eat and was happy. Darwin found this encounter one of the most thought-provoking of the entire voyage. He wrote about it at length. Here was a man who had been to England, who had spoken the language, worn the clothes, eaten the food, met the king, and who had returned within months to a life that looked, from the outside, entirely different. What did that mean? Was it a failure of the civilizing project as Fitzroy believed? Or was it something else? A demonstration that identity, culture, and way of life were not a thin surface that could be replaced by exposure to something else, but something deeper, more persistent, more genuinely the person's own? Darwin did not frame the question in those terms. Those are later terms, built from later thinking. But the question was there in what he wrote. He was troubled by his own earlier reaction to the Fuegians, the quick judgment that their simplicity meant inferiority. He wrote that the difference between a Fuegian and an Englishman was great, but the difference between a Fuegian and an animal was greater still. He was pushing back against the idea that the Fuegians were somehow less than human, even as he struggled to articulate what fully human meant. The encounter planted something in him that would grow slowly over the following decades, a sense that the differences between peoples were differences of circumstance and history, not of fundamental nature, and that the line between human beings and the rest of the animal world was the important one, not the lines between different groups of people. It was also, in a quieter way, asking the same question the fossils were asking. What shapes a living thing into what it is? The Fuegians had not changed their fundamental nature by going to England. Jemmy Button was still himself. And yet the environment had shaped him, and the return to his original environment had shaped him back. The fossils were asking something similar. What shapes a species into what it is? And why do species in the same region, across vast stretches of time, seem to share structural features even when they are clearly different creatures? The questions were not the same question, but they rhymed. The Beagle spent several weeks in the channels of Tierra del Fuego, surveying, taking measurements, moving carefully through the difficult waters. Darwin went ashore as often as he could, collecting plants and insects and marine invertebrates, noting the geology of the exposed rock faces. He found the landscape increasingly impressive the longer he spent in it. The glaciers carving into the water with a sound like distant artillery, the forest dark and dense right down to the shoreline. The channels sometimes so narrow the ship barely had room to turn. It was, he wrote, a place that made a person feel the smallness of human life against the scale of the natural world. And then the Beagle turned north again, back up the Argentine coast, and Darwin returned to the pampas and the fossils and the long open grasslands and the questions that had been building since Brazil. The southern tip of the continent had added something to those questions, a human dimension, a set of observations about people and culture and environment that would not sit neatly separate from the natural history questions, but would keep pressing up against them, asking to be included. Through early and mid-1833, the Beagle worked its way back up the coast, conducting surveys, taking measurements, stopping at various ports. Darwin made inland excursions when he could, sometimes for days at a time, riding across the pampas with local guides. He found more fossils. He observed more living animals. He wrote more notes. He was 24 years old, deeply tanned, considerably thinner than he had been when he left England, and increasingly confident in his ability to look at the natural world and see things that were worth seeing. The seasickness never fully went away. The ship's motion still made him miserable on rough days, and there were many rough days on the South American coast. But he had found a rhythm, suffer through the sailing, recover on shore, collect and observe and write with everything he had, then back to the ship and the hammock and the misery, and then shore again. It was not a comfortable life, but it was in a way he was beginning to recognise exactly the right life for what he was slowly becoming. The Andes were still ahead of him, the high passes, the marine fossils at 13,000 feet, the earthquake at Concepcion that would show him the living planet rearranging itself in real time. The Galapagos were further still, months away, still only a name on a chart. But the foundation was being laid, one fossil, one observation, one question at a time, in the cold channels of Tierra del Fuego, and the wide flat grasslands of Patagonia, and the long, slow, difficult miles of the South American coast. The ship was heading north, and then west, toward Chile, toward the mountains, toward a moment of violent geological revelation that would make everything Lyle had written feel suddenly, undeniably real. The Chilean coast arrived slowly, the way most things did on the Beagle, not as a sudden revelation, but as a gradual accumulation of new details replacing old ones. The grey-green waters of the South Atlantic gave way to the Pacific, and the landscape along the shore changed character. The cliffs were different here, the rock darker in places, the vegetation thinner where the desert pressed close to the water. Darwin had been at sea for over 2 years by the time the Beagle began its serious work along the Chilean coastline, and he was a different observer than the one who had left Plymouth. He was still seasick, that never changed. But he was sharper now, more purposeful, more capable of holding several questions in his mind at once without losing the thread of any of them. The Beagle spent much of 1834 working the Chilean coast, conducting the hydrographic surveys that were officially the entire point of the voyage. Fitzroy needed to measure depths, chart inlets, record the positions of rocks and shoals with enough precision that a Navy vessel could use the charts without running aground. This was painstaking, slow work, and it meant the ship spent long stretches anchored near shore or moving carefully through unfamiliar waters. For Darwin, this was useful. It gave him time ashore, and ashore, in Chile, there were mountains. He made several inland journeys into the Andes during this period, some of them quite demanding. The routes required mules, local guides, and a tolerance for altitude that Darwin had to develop as he went. The Andes are not gentle mountains. They rise steeply from a narrow coastal strip, and the passes between the peaks sit at elevations that leave lowland travellers short of breath and slow-moving. Darwin pushed himself through several of these crossings, driven by the same compulsive curiosity that had once led him to put a beetle in his mouth so he could free his hands for another specimen. What he found at altitude stopped him in a way that very few things had. At roughly 13,000 feet above sea level, embedded in the rock of the Andes, Darwin found marine fossils, shells, corals, the remains of creatures that had lived on the floor of an ocean. Not near the ocean, not at the base of the mountains, but high up in rock that had been pushed to an elevation where the air was thin and the cold was serious, and the nearest coastline was many miles below. He collected specimens carefully, turned them over in his hands, and thought about what they meant. He already had a framework for thinking about this, because he had been reading Lyell. Charles Lyell's Principles of Geology had been travelling with Darwin since the beginning of the voyage. Fitzroy had given him the first volume before they left Plymouth, and subsequent volumes had caught up with the ship at various ports along the way. Lyell's central argument was that the Earth was not shaped by sudden catastrophes, but by the same slow processes observable in the present day, operating over vast stretches of time. Rivers erode rock, sediment accumulates on sea floors, land rises and falls, volcanoes build and collapse. Given enough time, and Lyell was insisting on a great deal of time, far more than most people were comfortable with, these gradual processes could explain everything. Darwin had found this persuasive from the beginning. The shells embedded in the cliff face at Cape Verde, 45 feet above sea level, had been an early confirmation. The fossils of giant animals in the pampas, buried in rock that had once been sediment were another. But standing at 13,000 feet with a marine fossil in his hand was something different in scale. This was not a cliff 45 feet above sea level. This was the highest mountain range in the Western Hemisphere. The rock he was standing on had once been the floor of an ocean, and it had risen slowly over an incomprehensible span of time to where he was standing now. He sat with that thought for a while. Not metaphorically, he actually sat down, because the altitude made standing for long periods difficult, and because some thoughts need a moment of stillness before they settle properly into the mind. If the Andes had risen from the sea floor, then the Earth's surface was not fixed. It was not the stable, unchanging platform that most people assumed. It was mobile. Given enough time, it could do almost anything. The earthquake at Concepcion made this abstract understanding suddenly and viscerally real. On February 20th, 1835, Darwin was ashore near Valdivia, about 220 miles south of Concepcion. He had gone into the forest to rest. The Beagle was anchored offshore. Fitzroy was occupied with the survey work, and Darwin had found a patch of ground in the shade of the trees and was lying down. It was late morning, around 11 o'clock. The day was quiet. Then the ground moved. He described the sensation afterward with careful precision, which is one of the things that makes his account so useful. He was a trained observer even in the middle of being frightened. The ground did not simply shake. It seemed to become temporarily fluid, as if the solid rock beneath him had briefly lost its commitment to being solid. He could feel it moving in waves. He tried to stand and found it difficult, not because the shaking was violent enough to knock him down, but because the visual world and the physical world were suddenly disagreeing with each other in a way that the body does not know how to process. The trees swayed, the ground moved, the sky stayed still. The whole thing lasted approximately 2 minutes. 2 minutes is a long time when the ground is moving. He wrote that it was impossible to convey the strange feeling of insecurity that the movement produced. He was a young man who had spent years developing confidence in his ability to read the natural world, to find patterns in it, to understand what he was seeing. And here was the natural world doing something that bypassed understanding entirely and went straight to something older and more fundamental, the body's simple, animal knowledge that the ground is supposed to stay still. When the shaking stopped, he walked back to the beach and rejoined the ship. The immediate area around Valdivia had not suffered serious damage, but reports began arriving from further north. The Beagle sailed for Concepcion as quickly as it could. What Darwin found there was one of the most significant things he would see in 5 years of extraordinary observation. Concepcion was, or had been, one of the major cities on the Chilean coast, a substantial port with a cathedral, a harbour, several thousand inhabitants, and the kind of civic infrastructure that takes generations to build. By the time the Beagle arrived, the city had been almost entirely destroyed. The cathedral was in ruins. The walls of stone buildings had collapsed inward or outward. The streets were covered in rubble. The harbour had been struck by a tsunami shortly after the earthquake, and the combined effect of the shaking and the wave had left almost nothing standing. Darwin walked through the destruction and recorded what he saw with the same systematic attention he brought to fossil beds and coral reefs, which is an unusual thing to do in the middle of a catastrophe, but also exactly the right thing. The most significant observation was not the destroyed buildings. It was the harbour floor. The earthquake had not only shaken the ground, it had lifted it. The land around Concepcion and on the nearby island of Santa Maria had risen measurably. Darwin examined the shoreline carefully and found mussels, barnacles and other shellfish that had been living in the intertidal zone, some of them underwater, some exposed at low tide, now sitting several feet above the highest waterline. They were dead. They had been lifted out of their habitat by the rising of the land and left to dry in the air. On Santa Maria, the uplift was more dramatic still. Darwin estimated the land had risen roughly 8 to 10 feet in a single event. He stood on the shore and thought about what that number meant. 8 to 10 feet, in 2 minutes, in one earthquake. He wrote in his diary that it was one of the most interesting spectacles he had ever beheld, which is, by any measure, an extraordinary piece of understatement. The man had seen tropical rainforests, giant fossil sloths, glaciers carving into Patagonian channels, and the face of Jemmy Button returning to his homeland, and he was calling this the most interesting. But there was a reason for it. This was not just dramatic. This was Lyell's theory made visible and measurable in real time. Because if the land around Concepcion could rise 8 to 10 feet in 2 minutes, and if earthquakes like this had been happening along the Chilean coast for millions of years, which the marine fossils at 13,000 feet in the Andes strongly suggested, then the arithmetic was not complicated. Lift the land 10 feet every few centuries, do it for 10 million years, you get the Andes, you get mountain peaks with ocean shells embedded in them, you get a world whose surface is in constant, slow, enormous motion, rearranging itself according to forces that operate on a timescale so vast that a human life is not even a rounding error. Darwin wrote about this at length in his notes. He was not speculating wildly, he was following the logic of what he had seen. The earthquake at Concepcion was not an anomaly, it was a demonstration. It was the planet showing him, in compressed and violent form, what it had been doing quietly for an unimaginable stretch of time. There was something else the earthquake confirmed, and it was perhaps the deepest thing Darwin took from the Chilean experience. The world was old. Not just old in the way that ancient ruins are old, or old in the way that a grandparent is old. Old in a way that made the entire span of human civilization, every empire, every city, every written record, look like a thin, recent film on the surface of something that had been changing and moving and building and destroying itself for far longer than any human story. Lyell had argued for this kind of deep time in print, carefully and persuasively. But Darwin had now felt it through the soles of his feet. He spent several days around Concepcion, measuring, collecting, writing. The local population was beginning to sort through the rubble and assess what could be salvaged. Darwin noted the resilience of the people with the same quiet attention he brought to everything else. He was not a cold observer, but he kept his emotions in check in his scientific notes, letting them out more fully in his letters home. He wrote to his family about the earthquake with something close to excitement, which probably alarmed them, but which reflected the genuine intellectual thrill of having witnessed something so directly relevant to the questions he had been carrying for 3 years. The Beagle continued north along the Chilean coast after Concepcion, and Darwin made further inland excursions into the Andes. He crossed the mountains by the Portillo Pass in late March 1835, reaching Mendoza on the Argentine side before crossing back by a different route. At altitude, he found more marine fossils. He found evidence of ancient shorelines at different elevations. He found volcanic rock interbedded with sedimentary layers in ways that told a complicated geological story. Periods of volcanic activity, periods of quiet deposition, periods of uplift, all stacked on top of each other like pages in a very long book. He read these layers with the same patient attention he brought to the fossils in the Pampas, and they told him the same essential thing. The Earth was ancient, and it had been changing for the entirety of that ancient life. By the time the Beagle turned away from the Chilean coast and began heading northwest into the open Pacific, Darwin had been at sea for over 3 years. He was 26 years old. He had seen more of the natural world than almost any other person of his age and background, and he'd seen it with an attention that was becoming increasingly systematic, increasingly connected, increasingly able to hold different observations in relation to each other. The fossils in the Pampas, the Fuegians in the channels, the marine shells at 13,000 feet, the dead mussels above the waterline at Concepcion. Each of these things was interesting on its own, but they were beginning to form a pattern, not a clear, articulated theory, not yet, but a set of questions that were starting to pull toward each other, to suggest that they might all be asking in different registers the same fundamental thing about how the living and geological world worked. He did not know yet what the answer was. He was not close to knowing. The Galapagos was still ahead of him, 5 weeks on a set of volcanic islands that the world would later treat as the centre of everything, though Darwin himself would not fully understand what he had seen there until years after he left. But the earthquake at Concepcion had done something important to his thinking. It had made deep time feel real in a way that reading about it could not quite achieve. And once deep time felt real, once the mind genuinely accepted that the world had been rearranging itself for millions and millions of years, a great many things that had seemed fixed and permanent began to look rather more provisional. The Beagle left the Chilean coast behind and pointed west into the Pacific, carrying its charts, its chronometers, its 74 people, and one young naturalist whose notebooks were filling steadily with observations that would not make their full meaning clear for years. The Galapagos Islands lay roughly 2,000 miles ahead, a small chain of volcanic peaks rising from the ocean floor, home to creatures that had been developing in isolation for so long that they had become, in some cases, unlike anything found anywhere else on Earth. Darwin didn't know this yet. He knew only that they were on the chart, that the Beagle was heading for them, and that after 3 years of collecting and observing and questioning, he was ready, even if he could not have said exactly what he was ready for. The Beagle arrived at the Galapagos Islands on September the 15th, 1835. Darwin had been at sea for nearly 4 years by this point, and the sight that greeted him was not, by his own account, immediately beautiful. The islands were volcanic, black, jagged, raw-looking, as if the ocean floor had simply decided to push itself above the surface and had not yet gotten around to softening the result. The lava fields were sharp and broken. The vegetation on the lower slopes was sparse and strange. The air smelled of the sea and of sulphur in places, and the whole landscape had a quality Darwin described in his diary as resembling the cultivated parts of the infernal regions, which is a fairly vivid way of saying it looked like a very dramatic version of nowhere. He spent 5 weeks there in total, moving between 4 of the islands. The Beagle anchored at Chatham Island first, now called San Cristobal, then moved to Charles Island, which is today known as Floriana, then to Albemarle, the largest of the group and now called Isabella, and finally to James Island, present-day Santiago. 5 weeks is not a long time. Darwin was ashore for portions of that period, but the Beagle had survey work to do and did not stay anchored in one place for days on end. Darwin worked quickly, as he always did on shore, collecting, observing, making notes, packing specimens into bags and barrels for the ship. The first thing that struck him was the animals, specifically how completely unbothered they were by his presence. The birds did not fly away when he approached. The giant tortoises moved with the unhurried calm of creatures that had never encountered a predator. The marine iguanas, dark, almost prehistoric-looking things that sat in piles on the black rocks and dove into the surf to graze on algae, would simply shuffle aside if he nudged them with his foot. He noted this tameness carefully. It was not shyness overcome by patience. It was the absence of fear entirely, as if the concept had simply never been introduced. Darwin found it both remarkable and, in a practical sense, extremely convenient for a naturalist trying to collect specimens. The giant tortoises were among the first things he wrote about at length. They were enormous, some large enough that he tried riding one, which apparently worked, though not with any great dignity on either side. He watched them moving in slow processions toward freshwater springs in the island's interior, a journey that could take several days, and he noted that the locals who lived on Charles Island had a practical relationship with them. They were a reliable source of food and water both, since tortoises store significant amounts of liquid internally. Darwin ate several during his time in the Galapagos. He noted that the meat was good. He was not, at this stage, thinking of the tortoises as key evidence for anything. He was doing what he always did, observing carefully, writing things down and collecting what he could. It was the vice-governor of Charles Island, a man named Nicholas Lawson, who said something that should have stopped Darwin in his tracks. Lawson mentioned in the course of conversation that the tortoises on different islands had different shell shapes, and that he could tell, just by looking at a tortoise, which island it had come from. Tortoises from some islands had domed shells. Tortoises from others had shells that curved upward at the front like a saddle, allowing the animal to stretch its neck higher to reach vegetation. Darwin recorded this in his notes. He found it interesting, but he did not at the time fully register what it implied. He did not collect tortoises systematically by island. He did not make it a central focus of his remaining time there. He was busy, the ship was moving, and the significance of what Lawson had told him had not yet assembled itself into something he recognised as important. This is worth pausing on for a moment, because the popular image of Darwin in the Galapagos tends to be of a man having a slow, quiet revelation, standing on a black lava shore watching a finch crack open a seed and feeling the first tremor of a great idea. That is not really what happened. Darwin was busy, sometimes rushed, often distracted by the sheer volume of things to observe and collect. He was also, by this point in the voyage, experienced enough to know that interesting observations were everywhere, and that not every interesting thing would turn out to matter in the way it first seemed. He had been collecting for 4 years. He had seen a great deal. He had learned to be careful about over-interpreting individual observations before he had enough of them to compare. The birds are perhaps the most famous part of the Galapagos story, and they are worth getting right, because the popular version is slightly misleading. Darwin did notice the mockingbirds, and he noticed them carefully. He collected them on multiple islands, and he did label them by island. He noted in his diary that the mockingbirds on Charles Island appeared different from those on Chatham Island, and that those on James Island seemed different again. He wrote that this was a fact he found worth investigating. The mockingbirds were clearly a case where island differences were real and documented. The finches are a different matter. Darwin collected them, certainly. But he did not label them by island with the same care he applied to the mockingbirds. He also did not initially recognise them all as finches. He classified some as wrens, some as blackbirds, some as finches, some as grosbeaks. They were small brown birds of varying sizes, and without a specialist's eye, which Darwin did not have for birds specifically, the connections between them were not obvious in the field. He packed them up with his other specimens and moved on. The finches, which would eventually become perhaps the most famous birds in the history of science, left the Galapagos in a box, partially mislabelled, their significance entirely unrecognised by the man who'd collected them. What Darwin did notice, and notice clearly, was a more general pattern. The plants and animals of the Galapagos were clearly related to species he had seen on the South American mainland, similar in form, recognisably connected, but they were also distinctly different, not just a little different in ways that were consistent across the islands, and that seemed to reflect the specific conditions of the place. The Galapagos were only about 600 miles from the coast of Ecuador. Why were the species not simply the same as the South American ones? If animals had arrived here, blown by storms, carried on drifting vegetation, whatever the mechanism, why had they become something new, rather than simply remaining what they were? He also noticed the marine iguanas specifically. There was nothing quite like them anywhere else. They were lizards that had taken to the sea, diving and swimming and eating algae from the underwater rocks. On land they were clumsy and slow. In the water they were fluid and capable. Darwin found them ugly in a way he seemed almost fond of. He called them imps of darkness at one point, which is a phrase that has a certain affection in it despite the surface unflattery. He also noted the land iguanas, which were a different species entirely, living inland and eating cactus. 2 species of iguana on the same island chain, one adapted to the sea, one to the land, both clearly iguanas, both clearly different from anything on the mainland. The question of how they had come to be this way was one Darwin filed carefully in the back of his mind, alongside the tortoises and the mockingbirds and the fossils from the pampas and the marine shells at 13,000 feet. He spent his last days in the Galapagos on James Island, where he camped ashore for several nights while the Beagle continued its survey work. He collected plants, insects, lizards, fish, and more birds. He noted the freshwater springs, the vegetation zones at different altitudes, the way the higher ground was greener and cooler than the black lava shores below. He was thorough and energetic, as he always was on land, filling his days from early morning until the light failed. And then, in mid-October 1835, the Beagle weighed anchor for the last time in the Galapagos and turned west toward the open Pacific. Darwin left the islands without knowing what he had. He had 5 weeks of observations, a collection of specimens that would take months to sort and years to fully understand, and a set of questions that were interesting but not yet urgent. He had not experienced a revelation. He had not drawn any conclusions. He had noticed things, written them down, and moved on. The Galapagos were one stop among many on a voyage that had already included Brazil, Patagonia, Tierra del Fuego, the Falkland Islands, Uruguay, Argentina, Chile, and the Andes. They were remarkable, certainly. But Darwin had been remarking on remarkable things for 4 years. What makes this interesting, genuinely interesting, not just in hindsight, is that the evidence was all there. It was sitting in his collection boxes, labelled or partially labelled, waiting. The mockingbirds were there, carefully noted by island. The finches were there, imperfectly labelled but present. The tortoises were there, and Lawson's observation was in Darwin's notes. The pattern of mainland-related but island-distinct species was there. Everything that would later be cited as the foundational evidence for what Darwin was beginning to think about was in his possession when he left. He just had not yet understood what it was evidence for. That understanding would come later, in London, in a room, in conversation with a bird expert named John Gould. And when it came, it would reframe everything he had seen in those 5 weeks into something that looked, in retrospect, almost perfectly arranged to make a single point. But that is the thing about evidence. It does not arrive labelled with its own significance. Darwin collected it because he was curious and careful and trained to notice things. He did not collect it because he knew what he was looking for. He was not testing a hypothesis in the Galapagos. He was simply paying attention, as carefully as he could, to a set of islands that struck him as strange and worth recording. The meaning came later. The meaning almost always comes later. The Beagle sailed west from the Galapagos with a course set for Tahiti, carrying its charts and its chronometers, and its 74 people and one young naturalist who was, by this point, perhaps the most carefully observant person who had ever spent 5 weeks on those black volcanic shores. He did not know that yet. He was simply heading for the next island on the chart, watching the Galapagos disappear behind him into the Pacific haze, probably already thinking about what came next. The Pacific stretched out ahead, enormous and open, and the voyage still had nearly a year left to run. The Pacific is not a small thing to cross on a wooden ship 90 feet long. It is, by some measures, larger than all the land on Earth combined. When the Beagle turned west from the Galapagos in mid-October 1835, it was heading into the longest open stretch of water on the planet, and even with a good wind and a reliable hull, the crossing to Tahiti would take over 3 weeks. Darwin spent much of that time at sea doing what he always did at sea, which was suffering. The seasickness never really left him for the entire 5 years of the voyage. He had learned to manage it, to eat carefully, to lie still when the motion was bad, to work when the water was calm, but it did not go away. He read. He wrote up his notes. He organised specimens. He thought. By this point in the voyage, Darwin had been away from England for nearly 4 years, and his mind had accumulated an enormous amount of material. Not just specimens and measurements, but questions. Quiet, persistent questions that he had not yet tried to answer directly, but that kept surfacing whenever he reviewed his notes or sorted his collections. The fossils in Patagonia that looked like giant versions of living animals, the shells at 13,000 feet in the Andes, the land that had risen 8 to 10 feet in a single earthquake, the Fuegians who had returned to their original lives so completely and so quickly, the mockingbirds on different islands, the tortoises. All of it was sitting there, unresolved, like a room full of furniture that had not yet been arranged into anything recognisable. Tahiti arrived in November 1835 and Darwin was charmed almost immediately. He described the island as a place that exceeded his expectations, which for Darwin, who had already seen the Brazilian rainforest and the Andes, was saying something. The mountains rose steeply from the coast, green and dramatic. The people he encountered he described with genuine warmth and respect, noting their dignity and their ease. He walked inland with a small group of guides, following a river valley up into the mountains, sleeping one night on a ledge with a fire and a canopy of banana leaves above him. He found it peaceful in a way that the voyage had not often been peaceful. But what occupied his scientific attention in Tahiti was not the forest or the birds, it was the reef, specifically the coral reef that ringed the island, and the question of how coral reefs actually form. This was something Darwin had been thinking about since the Cocos and Keeling Islands were still weeks away. He had been developing a theory, quietly, as he developed most things, about the formation of coral atolls, those ring-shaped coral structures that sit in the open ocean with a lagoon in the middle and no visible island underneath them. The standard explanation at the time was that atolls grew on the rims of submerged volcanic craters. Darwin thought this was wrong. His idea was different, and it came directly from his geological thinking. If the seafloor could rise, as he had seen at Concepcion, it could also sink. If a volcanic island slowly subsided over thousands of years, the coral reef around its edges would continue to grow upward, keeping pace with the sinking, because coral grows toward the light and the surface. Eventually the island would disappear entirely below the water, and what remained would be a ring of coral, an atoll, surrounding a lagoon where the island had once been. The theory was elegant. It connected geology, biology, and deep time in a single idea. And when the Beagle later reached the Cocos Keeling Islands in the Indian Ocean, Darwin would be able to examine an actual atoll and gather evidence that supported his model. His theory of coral atoll formation, it turned out, was correct. It was confirmed by drilling in the 20th century, when cores taken from Pacific atolls revealed volcanic rock thousands of feet below the coral surface, exactly as Darwin had predicted. This is worth noting, not just as a footnote, but as a reminder of the kind of mind Darwin had developed by this point in the voyage. He was not simply collecting and cataloguing. He was forming theories, testing them against observation, and following the logic wherever it led. From Tahiti, the Beagle sailed to New Zealand, arriving in late December 1835. Darwin's response to New Zealand was considerably cooler than his response to Tahiti. He found the landscape interesting, but was troubled by what he saw of the early colonial situation, the tension between the Maori people and the European settlers, the disruption already visible in the land and the communities. He spent only a brief time there, and his diary entries have a restlessness to them, as if he was ready to move on. He noted the Kari forests, the thermal areas, the general strangeness of a place so remote from Europe and yet already being remade by European presence. He was not sentimental about it, but he was observant, and what he observed gave him a quiet unease that he did not fully resolve in his writing. Australia came next. The Beagle arrived at Sydney in January 1836, and Darwin spent several weeks exploring the country around it. He rode out to the Blue Mountains, those ancient sandstone ranges west of Sydney, that rise in a series of dramatic escarpments above deep forested valleys. He found the landscape unlike anything he had seen. The eucalyptus trees with their pale trunks and their narrow leaves, the dry air, the strange silence of a forest that seemed almost emptied of the dense animal noise he'd grown used to in Brazil. He noted the Aboriginal people he saw and wrote about them with a mixture of curiosity and concern for what colonization was doing to their way of life. He was not always right in his observations, and some of his assumptions reflect the limits of his time and background, but he was genuinely paying attention rather than simply passing through. Then came the moment that is perhaps the most quietly famous in all of Darwin's travel writing. He was sitting by a stream in the Blue Mountains when he saw a platypus. It moved through the water in front of him, that extraordinary animal with its duck-like bill and its beaver-like tail, furry and improbable and entirely real. Darwin watched it and wrote in his diary, and this is a line worth pausing on, that a disbeliever in everything beyond his own reason might exclaim that surely two distinct creators must have been at work. He meant it, as he later clarified, as something between a joke and a genuine philosophical observation. The platypus was so strange, so unlike anything in the European natural world, so apparently assembled from incompatible parts, that it seemed to challenge the idea of a single coherent plan behind all living things. Darwin did not press the thought further at that moment. He was not ready to. But the thought was real, and it lodged. The platypus was another piece of evidence that the natural world was stranger and more varied than any single tidy explanation could comfortably hold. The Beagle left Australia in March 1836 and crossed the Indian Ocean. The Cocos Keeling Islands came first, that coral atoll where Darwin tested his reformation theory and found the physical evidence he had been looking for. He spent several days there, wading through the shallow lagoon, examining the coral, measuring and noting the way the structure confirmed what he had predicted. It was one of the few moments in the voyage where a theory he had formed in advance was immediately supported by what he saw in front of him. He was pleased, though characteristically quiet about it in his diary. Then Mauritius, where he found the island beautiful, and the society there interesting in its mixture of cultures and histories. Then the Cape of Good Hope, at the southern tip of Africa, where he spent time in Cape Town and met the astronomer John Herschel, one of the most distinguished scientists in the world at that time. Darwin was nervous about the meeting and found Herschel impressive and warm. They talked about science and about the nature of species, and Darwin later said that Herschel's work had been one of the inspirations of his scientific life. It was a brief encounter, but it mattered to him. Then St. Helena, that remote island in the South Atlantic where Napoleon had died in exile just 15 years earlier. Darwin climbed the central ridge, noted the endemic plants, and found the landscape affecting in its isolation. Then Ascension Island, a volcanic outcrop in the middle of the Atlantic, where he spent a short time before the Beagle turned east again toward the South American coast. Fitzroy had decided to return briefly to Bahia in Brazil to recheck the chronometer readings, those precise time measurements that the entire surveying mission depended on. Darwin was not happy about this. He had been heading home, and now the ship was going backward across the Atlantic. He noted his irritation in his diary without much disguise, but there was nothing to be done about it. Fitzroy was the captain, and the chronometers were the point. Bahia came and went. The chronometers were checked. The Beagle turned north and east again. The Azores appeared, those Portuguese islands sitting in the mid-Atlantic, and Darwin spent a few days there collecting and walking. And then, finally, the course was set for England. The Beagle crossed the Bay of Biscay in early October 1836. On October 2nd, 1836, she arrived at Falmouth on the southern coast of Cornwall. Darwin was 27 years old. He had been at sea, more or less, for 4 years and 9 months. He had left England as an uncertain young man with a passion for beetles and no clear direction. He had come back with 60 notebooks, thousands of specimens, a head full of questions and a set of observations that would, in time, change the way every human being on the planet understood their own existence. Though he did not know that yet. On the evening of his arrival, he took a coach north toward Shrewsbury to see his family, and by the time the coach reached the first relay station, he was probably already thinking about his specimens and who should examine them. The voyage was over, but in a real sense the voyage was only the beginning. Everything Darwin had seen and collected and puzzled over for nearly 5 years was now sitting in boxes and notebooks and jars, waiting to be understood. The giant fossils were waiting. The Galapagos birds were waiting. The marine shells from the Andes were waiting. The coral atolls were waiting. The questions about the Fuegians and the tortoises and the iguanas and the 2-minute earthquake were all waiting. Darwin had gathered the raw material for a revolution in human thought, and he had done it with extraordinary patience and care and physical endurance, most of it while feeling profoundly unwell. What he had not yet done was sit still long enough to understand what all of it meant. That was what came next. And the first step in that process was handing his birds to an ornithologist named John Gould, and hearing what Gould had to say about the strange collection of Galapagos specimens that Darwin had, almost carelessly, labelled as various things on his way out of the islands. The answer Gould gave him would start a chain of thought that Darwin could not stop, even when he wanted to. John Gould was not a man who hedged. He was one of the finest ornithologists in England, possibly in the world at that point, and when he looked at a collection of birds, he gave you an answer. He had already produced major illustrated works on the birds of Europe and the Himalayan mountains, and he had a reputation for precision that made him exactly the right person to examine what Darwin had brought back from the Pacific. Darwin delivered his Galapagos bird specimens to Gould in January 1837, a few months after returning to England, and what Gould told him in the days that followed was the kind of thing that quietly rearranges the furniture of a person's mind. Darwin had collected the birds from the Galapagos with a certain amount of carelessness, at least by the standards of what he would later wish he had done. He had assumed, while he was there, that the various birds he was picking up were simply a mixed assortment of different species. Some finches, yes, but also what he thought were wrens, blackbirds and other distinct types. He had not labelled them carefully by island. He had not treated them as a single coherent group worth tracking in detail. He had been more interested in the reptiles and the geology, if we are being honest. The birds were collected, packed and shipped home along with everything else. Gould looked at them and saw something Darwin had missed entirely. These birds were not a scattered assortment of different species from different families. They were all finches, every single one of them. 12 distinct species, all clearly related, all from the Galapagos archipelago, and each one equipped with a beak that was shaped differently from the others. Some beaks were thick and heavy, designed for cracking hard seeds. Some were thin and pointed, suited for probing into cactus flowers or catching insects. Some were intermediate, somewhere between the two extremes. Gould recognised them immediately as a group, a closely related group that had, in his assessment, developed into distinct species within the islands themselves. This was not a trivial observation. What Gould was describing, in the careful language of a professional ornithologist, who was not yet thinking in evolutionary terms, was a pattern that made no sense under the standard view of creation. If species had been individually and separately created, why would 12 related finch species exist on one small island chain in the Pacific, each with a beak precisely calibrated to a slightly different food source? Why would the creator have placed 12 versions of essentially the same bird on these volcanic islands, differentiated only by the tool attached to their faces? The conventional answer had no good response to that question. Darwin, sitting in London in the early weeks of 1837, was beginning to understand that he had been carrying the answer in his specimen boxes without knowing it. There was a practical problem, though. Darwin had not labelled the finches by island. He had collected them from at least 4 different islands, but had not consistently recorded which bird came from which. This mattered enormously, because the pattern Gould was describing implied that related species had diverged on different islands, and without knowing which bird came from where, Darwin could not demonstrate that island separation was the mechanism. He had to go back through the records of everyone else on the ship. Fitzroy had kept birds. So had Fitzroy's servant Sims Covington, who had worked as Darwin's assistant during the voyage, and so had other crew members. Darwin wrote to them, compared notes, and was able to partially reconstruct the geographic origin of his specimens. It was not perfect. He always regretted the gap, but it was enough to establish the pattern, and it was not just the finches. Gould also confirmed something Darwin had noticed and noted carefully in the Galapagos: the mockingbirds. Darwin had collected mockingbirds from 3 different islands and had actually labelled those correctly, because he had suspected at the time that they might be distinct. Gould confirmed it. 3 separate mockingbird species, one from each island, all clearly related to South American mockingbirds, but distinctly different from each other and from their mainland relatives. This was the cleaner piece of evidence, the one Darwin had actually collected with some care. 3 islands, 3 species, all variations on the same theme. The tortoises added another layer. The governor of Charles Island had told Darwin, almost in passing, that you could tell which island a tortoise came from by the shape of its shell. Darwin had noted this, but had not initially taken it seriously enough to act on it carefully. He had eaten several of the tortoises during the visit, which he later found grimly ironic given how important they turned out to be. But the pattern held. Tortoises from different islands had different shell shapes, different proportions, different sizes. They were the same animal, recognisably, but they were not identical. Island by island, the tortoises had diverged. The picture that was assembling itself in Darwin's mind by early 1837 was something like this. The Galapagos Islands sat 600 miles off the coast of South America. At some point in the past, animals and plants from the South American mainland had reached those islands, carried by wind, by ocean currents, by accident. Once there, they had found themselves in a new environment, cut off from the mainland, separated from each other by stretches of open water between the individual islands. Over time, and Darwin did not yet know how much time, they had changed. Not dramatically, not into something unrecognisable, but enough. The finches had become 12 species instead of 1. The mockingbirds had become 3. The tortoises had diverged island by island. The flora was related to South American plants but distinctly Galapagos in character. The animals were South American in their ancestry, but Galapagos in their present form. In March 1837, Darwin opened a new notebook. He labelled it the Bee Notebook, and on its pages he began writing out something he'd been circling around for months. The idea that species were not fixed, that they changed over time, that one species could give rise to another. He used the word transmutation, which was the term of the moment for what we would now call evolution. He was not the first person to use the word or to entertain the idea. His own grandfather Erasmus had speculated about something similar decades earlier. The French naturalist Jean-Baptiste Lamarck had proposed a theory of species change in the early 1800s, but those earlier ideas had lacked a clear mechanism, a convincing explanation for how change actually happened, what drove it, what made one variation survive while another disappeared. Darwin did not have that mechanism yet either, but he was thinking hard about it, and the notebook was where he did his thinking. He filled it with questions, observations, diagrams, and half-formed ideas, and then, on one particular page, he drew something that has become one of the most reproduced scientific sketches in history. It was a simple branching diagram, a small tree drawn in pencil, with the lines diverging from a common point, each branch representing a different species descending from a shared ancestor. He wrote at the top of the page in his slightly cramped handwriting the words, "I think." Just that, "I think." And then the diagram below it, showing species not as fixed and separate creations but as branches from a common trunk, related by descent, diverging over time. He was 28 years old. The diagram was not elaborate. It was the kind of thing a person draws when they are trying to get an idea out of their head and onto paper before it escapes. But it contained the essential structure of what would eventually become the theory of evolution by common descent. Every living thing on Earth is related to every other living thing, connected by a branching history of shared ancestry going back, in principle, to a single origin. The finches are related to each other because they descended from a common finch ancestor. The mockingbirds are related to South American mockingbirds because they came from there. The tortoises are related island to island because they descended from the same ancestral stock. And all of them, finches and mockingbirds and tortoises and humans and beetles and barnacles, are connected somewhere further back in the branching diagram, if you trace the lines far enough. Darwin could feel the shape of the idea. He could see that it fit the evidence from the Galapagos, from the fossils in Patagonia, from the marine shells in the Andes, from the earthquake at Concepcion, from the platypus in Australia. All of those observations, scattered across 5 years and 40,000 miles, were pointing at the same thing. The natural world was not a static arrangement of fixed types. It was a dynamic, changing, branching history. Species were not created once and placed permanently in their positions. They were the current endpoints of long journeys through time, shaped by their environments, changed by circumstance, always in the process of becoming something slightly different from what they had been. But knowing the shape of an idea is not the same as knowing how it works. Darwin had the pattern. He did not yet have the mechanism, and without the mechanism, the idea was suggestive but not convincing. You could say that species change, but if you could not explain how or why, you had not really explained anything. The question that pressed on him through 1837 and into 1838 was, what actually drives the change? What is the force that pushes a population of finches toward a new beak shape? What determines which individuals survive and which do not? What is the engine underneath the pattern? He would find the answer, though not yet. It was still more than a year away, and it would come from an unexpected source. Not from nature at all, but from a book about human population and poverty. The specimens had done their work. Gould had given Darwin the confirmation he needed. The notebooks were filling up. The question was sharpening. And somewhere in the background of all this thinking, quietly and without any particular fanfare, the most consequential scientific idea in the history of biology was beginning to take its full shape. The Galapagos, in a way, had been the key, but only after the fact. Darwin had not understood the islands while he was standing on them. He had walked among the iguanas and the tortillas and the strange black lava fields, and thought them interesting and unusual, without fully grasping what they were telling him. The understanding came later, in London, in conversation with Gould, in the careful reconstruction of specimen labels, in the slow accumulation of pattern from the evidence he had gathered. This is worth holding on to for a moment. The famous insight did not happen in the field. It happened in a room, with a notebook, after someone who knew more about birds than Darwin did looked at his collection and told him what he was actually looking at. The Voyage gave Darwin the raw material. The experts in London helped him read it, and his own mind, patient and relentless and deeply unwilling to accept easy answers, did the rest. That combination, field observation, expert consultation, and long solitary thinking, was how the theory was built. Not in a single flash of inspiration on a volcanic island, but piece by piece, over years, in the quiet work of a man who had learned to look at the natural world with extraordinary care and was now beginning to understand what he had seen. What came next was the harder part. Darwin had the pattern and was closing in on the mechanism. But having a revolutionary idea and being willing to publish it were two very different things, and Darwin was not yet anywhere close to ready for that second step. The notebooks kept filling, the questions kept sharpening, and the mechanism, when it finally arrived, would come to him not from the Galapagos or from any natural landscape at all, but from a thin book about human suffering that he picked up one afternoon in September 1838 and could not put down. The book was Thomas Malthus's essay on the principle of population. It had been published in 1798, 40 years before Darwin read it, and it was not a book about nature. It was a book about people, about poverty, hunger, birth rates, and the brutal arithmetic of survival in human societies. Malthus's argument was stark and uncomfortable. Populations left unchecked will always grow faster than the food supply available to sustain them. More children are born than can be fed. More people exist than the resources can support. The result, inevitably, is competition, scarcity, and death. Not as an accident or a moral failure, but as a mathematical certainty built into the structure of living things. Darwin read it in September 1838, about 18 months after he had opened his first transmutation notebook and begun sketching the branching diagram of life. He was 29 years old, living in London, working through the enormous pile of intellectual questions the voyage had left him with. He was not reading Malthus because he expected it to be relevant to his thinking about species. He was reading it, as he later said, for amusement, which tells you something about Darwin's idea of light reading. But somewhere in those pages, something connected. If more individuals are born than can survive, then survival is not guaranteed. It is earned, or rather, it is the result of some individuals being better suited to their circumstances than others. And if individuals within a species vary, which Darwin knew they did because he had spent years collecting specimens and noticing that no two were exactly alike, then those variations would affect survival. A bird with a beak slightly better suited to cracking hard seeds would eat more, survive longer, and produce more offspring. A bird with a beak slightly less suited would eat less, survive less well, and leave fewer offspring. Over many generations, the population would shift. The better suited beak shape would become more common. The less suited shape would become rarer. The character of the population would change, not through any conscious intention, not through any guiding hand, but simply through the accumulated result of which individuals survived long enough to reproduce. Darwin called it natural selection. The word selection was deliberate. It echoed what animal breeders did when they chose which individuals to breed from, selecting for desired traits, producing dogs with shorter legs or pigeons with fancier tail feathers over just a few generations. But in nature, there was no breeder making the choices. The environment itself was doing the selecting, invisibly, continuously, over enormous stretches of time. Individuals that fit their environment reproduced. Individuals that did not fit their environment died before they could. The environment was the selector, and its criterion was simple: survival long enough to leave offspring. It was, in retrospect, a beautifully simple idea. Simple enough that Huxley, when he finally read it 20 years later, would slap his forehead and say he couldn't believe he hadn't thought of it himself. But simple ideas are not always obvious ones, and the clarity of the mechanism only becomes apparent once someone has assembled all the right pieces in the right order. Darwin had spent years gathering those pieces: the finches, the fossils, the geological change, the Fuegians, the barnacles, the breeding records, the thousands of careful observations, and Malthus supplied the last one. The logic snapped into place. He wrote it down. Not in a published paper, not in a letter to a colleague, but in his private notebook, in the careful private language of a man who knew he was holding something explosive and was not at all sure what to do with it. He understood immediately that natural selection applied consistently could explain not just the variation between finches on different Galapagos islands, but the entire pattern of life on Earth, every adaptation, every species, every branching in the tree of life. All of it could be produced given enough time by the simple, repeated action of differential survival and reproduction. You did not need a creator designing each species separately. You needed variation, inheritance, and selection operating over millions of years. The rest would follow. In 1842, 4 years after reading Malthus, Darwin wrote out a brief sketch of the theory. It was 35 pages, written in pencil, working through the logic step by step. He was living at Down House in Kent by then, having moved out of London partly for health reasons and partly because he needed quiet. He read the sketch over and was satisfied that the argument held. Then he put it away. In 1844, he expanded it into a longer essay, 230 pages, written more carefully, more fully argued. He gave a copy to his wife, Emma, with a letter attached. The letter asked her, in the event of his death, to publish the essay. He suggested she might find a suitable editor and offered a sum of money, £400, to support the work. He was 35 years old. He was not ill, or not especially so. but he understood that what he'd written was important enough that it should not disappear if something happened to him before he was ready to publish it himself. Then he put that away too. What followed was one of the stranger episodes in the history of science. Darwin had in his drawer a fully developed theory of natural selection. He had the mechanism, he had the evidence, he had the argument, and he did nothing with it publicly for 15 years. He was not idle during those years, quite the opposite. He threw himself into an enormous study of barnacles, the small shell-covered crustaceans that attach themselves to rocks and ships and whale skin. He collected specimens from around the world, dissected them, described them, classified them, corresponded with naturalists everywhere. He published 4 volumes on barnacles between 1851 and 1854, 2 on living species and 2 on fossil species. It was painstaking, exhausting, deeply detailed work, and it took 8 years of his life. His children, growing up at Down House, apparently assumed that all fathers spent their days bent over microscopes examining barnacles. One of his sons, visiting a friend's house, reportedly asked where the friend's father kept his barnacles. The barnacle work was not a distraction, Darwin understood that before he could make the most radical claim in the history of biology, he needed to establish himself as a serious, rigorous, credible naturalist. He needed the scientific community to know that he was not a dilettante. The barnacles gave him that credibility. By the time he finished, he was recognised as one of the leading experts in invertebrate taxonomy in Britain. When he eventually published his theory, no one could dismiss him as an amateur who had spent a few years on a ship and come home with some half-formed ideas about birds. But there was more to the delay than strategic credibility building. Darwin was genuinely afraid. He knew what he was saying. He had grown up in a religious culture, married a deeply religious woman, and lived in a society where the dominant understanding of life on Earth was that God had created each species separately, deliberately, and completely. His theory did not just complicate that picture, it replaced it. Natural selection required no designer. It produced the appearance of design, the exquisite fit of a woodpecker's beak to the bark of a tree, the perfect camouflage of a moth against a lichen-covered wall, without any designing mind behind it. The appearance of purpose in nature was, on Darwin's account, an illusion produced by the long operation of a blind and automatic process. He knew this would hurt people. He knew it would be seen as an attack on faith. He knew it would provoke a reaction that would be personal as well as scientific. He wrote to his friend Joseph Hooker, the botanist, in January 1844, disclosing the theory for the first time. He described it as like confessing a murder. The phrase has been quoted so often it has almost lost its weight, but it is worth sitting with for a moment. Not like announcing a discovery, or like sharing a controversial idea. Like confessing a murder, the language of guilt, of transgression, of something done that cannot be undone. Darwin was not being dramatic for effect. He genuinely felt the weight of what he was saying, and the weight was not just intellectual. Hooker received the disclosure and responded with cautious interest. He was not immediately convinced, but he took it seriously and became one of Darwin's closest confidants. Charles Lyell, the geologist whose book had shaped Darwin's thinking from the very beginning of the voyage, was also told eventually. Lyell urged Darwin to publish. So did Hooker. Darwin kept revising, expanding, adding evidence, finding objections and answering them. He was building a case so thorough that it could not be easily dismissed, but he was also, it seems clear, simply not ready. The theory was ready. Darwin was not. The years passed. Darwin's health was poor. It had been poor since the voyage, a chronic pattern of nausea, exhaustion, and heart palpitations that would follow him for the rest of his life. He worked in short sessions, rested often, took long walks on the sandwalk, the gravel path he had laid out in the garden at Down House, which he called his thinking path. He would pace it in the mornings, counting laps with a pile of stones he kicked aside one by one, using the rhythm of walking to work through problems. The theory was always there, in the background, waiting. In the early 1850s, he began work on what he conceived as a massive definitive book. He called it Natural Selection, and he intended it to be so comprehensive, so exhaustively argued, that no serious scientist could dismiss it. He worked on it slowly, chapter by chapter. By 1858, he had completed several chapters and was nowhere near finished. The book, if completed as planned, might have been 2 or 3 times the length of what was eventually published. It might have taken another decade. Then, in June 1858, a letter arrived from the other side of the world. Alfred Russel Wallace was 35 years old, self-educated, and working as a professional specimen collector in the Malay Archipelago, the islands of present-day Indonesia and Malaysia. He had been thinking about the species question for years, independently of Darwin, and had already published some work that gestured toward the idea of species change. In February 1858, while lying ill with malaria on the island of Ternate, a small volcanic island in the Maluku group, about as far from Downhouse in Kent as it is possible to get, Wallace had a clear and sudden insight. He thought through the same Malthusian logic Darwin had worked through 20 years earlier. More individuals born than can survive. Variation among individuals. Differential survival. Change in populations over time. Natural selection, though he did not use that exact phrase. He wrote it up in a few hours or days, the accounts vary, and sent the paper to Darwin, asking him to pass it on to Lyell if he thought it worthwhile. Darwin received it and was, by his own account, devastated. He wrote to Lyell immediately, "All my originality will be smashed." He had been sitting on the theory for 20 years, and now here was a younger man working alone in the tropics who had arrived at essentially the same idea independently. Everything Darwin had been building toward, the credibility, the exhaustive evidence, the careful strategy of publication, all of it was suddenly at risk of being rendered irrelevant. Wallace had not yet published, but he would, and when he did, Darwin would appear to have been anticipated, or worse, to have borrowed from a man who had beaten him to it. Lyell and Hooker moved quickly. They arranged a solution that was, depending on how you look at it, either admirably fair or quietly convenient for Darwin. A joint presentation was organised at the Linnean Society of London on July 1st, 1858. Darwin's 1844 essay, the one he'd written 14 years earlier and given to Emma with instructions for posthumous publication, was read aloud, along with a letter Darwin had written to the American botanist Asa Gray in 1857 that outlined the theory. Wallace's paper was read immediately afterward. Neither Darwin nor Wallace was present. Darwin was at home, grieving. His infant son Charles, Waring Darwin, had died of scarlet fever just days before. The audience at the Linnean Society received the joint presentation with what can only be described as polite indifference. The president of the society, in his annual review of the year, noted that 1858 had not been marked by any striking discoveries. He was wrong about that, as it turned out, in a fairly spectacular way. But the reaction would come later, and it would come with force. Darwin spent the next 13 months writing. Not the massive multi-volume work he had planned, but a compressed version, an abstract as he called it, though it ran to nearly 500 pages. He worked harder than he had in years, driven now by urgency rather than the slow patience of the previous 2 decades. He finished it, handed it to his publisher John Murray, and on November 24th, 1859, On the Origin of Species by Means of Natural Selection, or The Preservation of Favoured Races in the Struggle for Life, was published in London. The first edition was 1,250 copies. They sold out on the day of publication. Darwin was 50 years old. He had been carrying the essential idea for 21 years. The voyage that had given him the raw material had ended 23 years earlier. The young man who had boarded the Beagle in Plymouth in December 1831, uncertain and slightly seasick before the ship had even left the harbour, had become the author of the most consequential scientific book of the 19th century. possibly of any century. But the book's arrival in the world was only the beginning of a different kind of story. Darwin had spent 2 decades worrying about the reaction, turning it over in his mind, imagining the arguments that would be made against him. Now those arguments were coming from every direction at once. From scientists, from clergymen, from newspapers, from old friends and former teachers. The theory was out, and the world had opinions about it. Strong ones. The reaction, when it came, was not a single wave. It was more like a tide coming in from multiple directions at once, each current carrying its own particular temperature. Some of it was warm, even excited. Some of it was cold and hard, and some of it came from people whose opinions Darwin had genuinely dreaded, not because they were powerful, but because he respected them, and their disapproval cost him something. Thomas Henry Huxley was among the first to read the book, and his response has become one of the more famous moments in the history of science. He wrote to Darwin shortly after finishing it, and somewhere in that letter, between the careful scientific praise, he included a line that has been quoted ever since. He said he was astonished at how stupid it was not to have thought of it himself. That is not a direct quotation, but the spirit of it is right. Huxley was a biologist and comparative anatomist who had no particular attachment to the idea of fixed species, and when he read Darwin's argument laid out in full, the logic struck him as almost obvious in retrospect. He became, almost immediately, one of Darwin's most committed public defenders. People would come to call him Darwin's bulldog, a nickname Huxley seemed to wear with some satisfaction. He was a far more comfortable public fighter than Darwin ever was, and he understood that the theory needed advocates who could stand in rooms full of hostile people and not flinch. Joseph Hooker, the botanist who had been one of Darwin's trusted confidants for years, also responded with support. He had known the theory was coming for a long time, had read early drafts, had argued with Darwin about the evidence over many letters and dinners. When the book finally appeared, Hooker did not need to be persuaded. He had already done his persuading in private. But not everyone was generous. Richard Owen was, at the time, the most prominent anatomist in Britain. The man who had coined the term dinosaur, who had described many of Darwin's own beagle fossils, who ran what would become the Natural History Museum in London. Owen read The Origin and disliked it intensely. He wrote an anonymous review in the Edinburgh Review that was scathing in its criticism, picking apart Darwin's arguments and defending the idea that species were created separately and distinctly. The review was long, technically detailed, and written with the authority of someone who knew the material well. Darwin eventually discovered that Owen had written it, and the knowledge stung. The two men had once been on civil terms. After the review, they were not. Adam Sedgwick, Darwin's old geology teacher from Cambridge, the man who had taken a young Darwin on a field trip through Wales in the summer of 1831, just months before the Beagle voyage, wrote a personal letter to Darwin that was perhaps harder to read than any anonymous review. Sedgwick told Darwin that parts of the book had given him great pleasure, but that other parts had filled him with pain. He could not accept the theory. He believed it severed the link between the natural world and its moral foundation, that if species were not designed and created, then the whole framework of purpose and meaning that he saw embedded in nature would dissolve. He was not angry exactly, he was grieved, and Darwin, who had genuine affection for Sedgwick, found that grief difficult to receive. Then there was the church. The reaction from religious quarters was not, it should be said, uniformly hostile. Some clergymen read The Origin and found ways to reconcile it with their faith. The idea that God might have worked through natural processes rather than direct creation was not, for everyone, an impossible thought. Charles Kingsley, the novelist and clergyman, wrote to Darwin saying he had gradually learned to see that it was just as noble a conception of the deity to believe that he had created a few original forms capable of self-development, as to believe that he had required a fresh act of creation to supply the voids caused by the action of his laws. Darwin was pleased enough by this that he included a version of it in later editions of the book, but other voices in the church were far less accommodating. The idea that human beings were descended from earlier animal forms, a conclusion Darwin had carefully avoided stating explicitly in the origin, though it was obviously implied, was, for many, simply unacceptable. The confrontation that has come to define the public battle over evolution in those early years happened in Oxford on June 30th, 1860, at a meeting of the British Association for the Advancement of Science. The meeting was held at the Oxford University Museum of Natural History, a building that had only just been completed, its stone pillars and iron arches still smelling faintly of new construction. The room was packed. Estimates of the crowd vary between 400 and 1,000 people, depending on the source, and the number has probably grown with each retelling. What is certain is that a great many people were there, that the room was warm, and that the atmosphere was charged. Bishop Samuel Wilberforce was the church's most eloquent and confident voice on scientific matters. He was known as Soapy Sam, a nickname that reflected both his rhetorical smoothness and the suspicion that his charm concealed more than it revealed. He had been coached, at least in part, by Richard Owen, and he came prepared with arguments. He spoke at length, with confidence and wit, attacking the theory on scientific and theological grounds. He was good at this. He knew how to hold a room. Then, near the end of his remarks, he turned toward Huxley, who was seated on the platform, and asked, with what appears to have been a light smile, whether it was on his grandfather's or his grandmother's side that he claimed descent from an ape. The exact words are lost. No transcript was taken. The accounts that survive were written down years later by people who were there, but whose memories had been shaped by the intervening years and by the legend the moment had already begun to generate. What Huxley said in response is also disputed in its precise wording, but the substance is generally agreed upon. He said something to the effect that he would rather be descended from an ape than from a man who used his gifts and position to introduce ridicule into a serious scientific discussion, or words very close to that. The crowd erupted. A woman reportedly fainted. A man named John Brodie Innes, who was a friend of Darwin's, later said the response had been electric. Others who were there described the moment differently, some remembering Huxley's words as devastating, others suggesting the bishop recovered well and held his ground. The truth is probably somewhere in the middle. It was not a clean knockout. Wilberforce had supporters in that room and they were not silent. But the exchange lodged itself in the popular memory of the moment as a turning point. The day that evolutionary theory stood up in public and refused to be laughed away. Darwin was not there. He was almost never there for these moments. His health had been deteriorating through the late 1850s, and the months following publication were particularly difficult. He was at home in Downhouse in Kent, following the Oxford meeting through letters from Hooker and Huxley, reading their accounts with a mixture of relief and exhaustion. He had known the confrontation was coming. He had spent 2 decades dreading something exactly like it. Now it had happened, and his friends had carried it for him. Hooker's account of the meeting, written to Darwin shortly after, was vivid and detailed. He told Darwin that he had spoken himself, a fact that is sometimes forgotten in the retelling, which tends to focus entirely on Huxley. Hooker said he had taken Wilberforce apart on the botanical evidence point by point, and that the bishop had not been able to answer him. Darwin read this with something that might have been quiet satisfaction, though he expressed it modestly as he usually did. The book continued to sell. A second edition appeared in January 1860, just weeks after the first had sold out, with small revisions. A third edition came in 1861, a fourth in 1866, a fifth in 1869, a sixth in 1872. Each edition carried Darwin's responses to critics, new evidence, refined arguments, and occasional concessions where he felt the criticism had been fair. The sixth edition added the phrase survival of the fittest, borrowed from the philosopher Herbert Spencer, in addition to natural selection, a decision Darwin later seemed ambivalent about. The book evolved, in a sense, across its own editions, shaped by the pressure of the environment around it. Wallace, for his part, responded to the joint Linnean Society presentation and the subsequent publication of The Origin with a generosity that surprised almost everyone, including Darwin. He wrote publicly and privately that Darwin deserved full credit for the theory, that Darwin had developed it first and most completely, and that the priority was not in question. He called Darwin the Newton of natural history. He continued to correspond with Darwin for years, warmly and productively, even when the two men disagreed. And they did disagree, most notably on the question of human evolution, where Wallace believed that natural selection alone could not account for the higher faculties of the human mind, and that some additional force must be at work. Darwin found this position frustrating, and said so, though carefully. The relationship between the two men is one of the quieter, more interesting threads in this whole story. Wallace had arrived at the same idea independently, sent it to the man who had been sitting on it for 20 years, and then, when that man received the credit and the fame, responded not with bitterness, but with apparent sincerity. Whether Wallace was entirely at peace with how things had unfolded, or whether he simply presented a peaceful face to the world, is something historians have debated without resolution. What is clear is that Wallace continued his own scientific work with energy and independence for the rest of his long life. He lived until 1913, outliving Darwin by 31 years, and that he never publicly claimed to have been wronged. Darwin, for his part, acknowledged the debt clearly and often. He referred to the theory as having been independently discovered by Wallace. He supported Wallace in various practical ways over the years, including lobbying for a government pension for him. The two men were never close friends in the way Darwin was close to Hooker or Lyell, but the connection between them was real and, on the surface at least, respectful on both sides. What the Wallace episode reveals, more than anything else, is how close the theory had been to the surface of the scientific conversation by the late 1850s. Two men, working independently on opposite sides of the world, one in a quiet English country house, one in a fever on a volcanic island in the Maluku Sea, had arrived at the same fundamental idea within roughly the same decade. The intellectual conditions were ready. The evidence from natural history, from geology, from biogeography had been accumulating for years. Darwin had assembled it most carefully and most completely, but the idea itself was, in some sense, waiting to be found. It just happened to be Darwin who had spent the most time looking. The publication of The Origin did not end the debate, of course. It opened it. The arguments about mechanism, about the completeness of the fossil record, about the inheritance of variations. Darwin had no knowledge of genetics, and the mechanism by which traits were passed from parent to offspring remained unclear to him throughout his life. These arguments would continue for decades. It would take the rediscovery of Gregor Mendel's work on pea plants in the early 20th century, and then the development of population genetics in the 1920s and 1930s, to fuse Darwin's natural selection with a proper understanding of heredity. That fusion, known as the modern synthesis, produced the framework that still underlies evolutionary biology today. But in 1859 and 1860, standing in the immediate aftermath of publication, what Darwin had done was simpler and more profound than any technical debate could capture. He had given the natural world a history. He had shown that the species alive today were not the same as the species that had always existed, that life had changed over time, that change had a mechanism, and that the mechanism required no designer, no divine intervention, no separate act of creation for each form. The tree of life that he had sketched in his notebook in 1837, a branching diagram with a single root, was not just a metaphor. It was a description of how things actually were. That idea, once it was out in the world, could not be put back. The arguments would continue, the revisions would come, the science would deepen and complicate and refine itself in ways Darwin could not have imagined. But the essential claim that all living things are related, that they share common ancestors, that they have been shaped by the slow pressure of differential survival across immense stretches of time, had been made clearly and publicly, with enough evidence to make dismissal genuinely difficult. Darwin had not wanted to rush it. He had wanted to be so thorough, so complete, so unassailable that the argument would settle itself. The letter from Wallace had taken that dream away from him and replaced it with urgency. And urgency, as it turned out, had produced something better than the massive unfinished book ever would have. It had produced something people could actually read. The world had the theory now. And what it did with that theory, in the decades and centuries that followed, in the laboratories and lecture halls and courtrooms and churches and schoolrooms, is a story that has never quite stopped unfolding. But Darwin himself, at 50 years old, having published the book that would define his life and reshape the world's understanding of its own biology, now retreated to Down House, to his greenhouse, to his sandwalk, and to the next set of questions. Because for Darwin, there was always a next set of questions. The theory was not a destination. It was, in a way, just another place from which to keep looking. The book had been out in the world for a matter of weeks when the arguments began arriving from every direction. Some were careful and scientific, some were personal, some were philosophical in the broad, uncomfortable way that philosophical arguments tend to become when they touch something people have organised their lives around. Darwin read the reviews from Down House, often through the filter of letters from Huxley or Hooker, and responded to them in his quiet, methodical way, acknowledging good points, defending weak ones, occasionally expressing mild exasperation in private while remaining measured in public. He had expected resistance. He had spent 20 years dreading it. What he had not fully anticipated was how quickly the debate would take on a life of its own, moving out of the pages of scientific journals and into drawing rooms, pulpits, newspapers, and dinner party conversations across the country. Thomas Henry Huxley was the person most responsible for that acceleration. He was 34 years old when The Origin was published, a comparative anatomist with a sharp mind and a sharper tongue, and he had been looking for exactly this kind of fight. When Darwin sent him a copy of the book before publication, Huxley wrote back with the line that has been quoted ever since: "How extremely stupid not to have thought of that." It was not just a compliment, it was a declaration of allegiance. Huxley understood immediately what Darwin had done, and he understood just as immediately that Darwin himself was not the person to defend it in public. Darwin was cautious, anxious, physically fragile, and deeply reluctant to engage in confrontation. Huxley was none of those things. He stepped forward as the theory's most visible champion, with what seemed like genuine enthusiasm for the contest. He reviewed The Origin in the Times in December 1859, anonymously, as was the custom, and the review was long, clear, and favourable. He wrote other pieces, gave public lectures, and made himself available as the person journalists and editors could approach for a comment. He called himself Darwin's bulldog, a description that suited him well. He was not a blind advocate. He had his own reservations about parts of the theory, particularly about whether natural selection could be demonstrated to produce change between species rather than just within them. But he believed the core argument was sound and worth defending, and he defended it with considerable vigour. Richard Owen took the opposite position, and he did so with a venom that surprised even people who knew him well. Owen was the most prominent comparative anatomist in Britain. He had been the one to formally describe the Megatherium fossils that Darwin had sent back from South America, and he had coined the word dinosaur. He was brilliant, ambitious, and deeply invested in a view of nature that Darwin's theory directly undermined. Owen believed in what he called archetypes, ideal forms that existed in the mind of the creator and were expressed imperfectly in living things. Darwin's argument had no room for archetypes. It had only variation, selection, and time. Owen wrote a hostile anonymous review of The Origin in the Edinburgh Review in 1860, praising the book's observations while attacking its conclusions, and implying that Darwin had not given proper credit to earlier thinkers, including Owen himself. Darwin recognised the style immediately and was hurt by it, though he tried not to show it. The two men had been on friendly terms before the book. They were not after it. Adam Sedgwick, Darwin's old geology teacher at Cambridge, wrote to him directly. The letter was pained rather than hostile, which in some ways made it harder to read. Sedgwick was in his mid-70s by then, a man who had spent his life studying the rocks of Wales and the north of England, who had helped establish the geological record that Darwin himself had drawn on so heavily. He told Darwin that the book had given him more pain than pleasure. He said that Darwin had abandoned the true method of induction and had gone on a speculative path that led away from the truth. He was not cruel about it. He seemed genuinely sad. Darwin replied with respect and without changing his mind. The Church of England's response was more complicated than the popular version of this story usually suggests. It was not a single, unified wall of opposition. Some clergy accepted the theory with relatively little difficulty, arguing that evolution was simply the mechanism God had used. Frederick Temple, who would eventually become Archbishop of Canterbury, gave a sermon in 1860 that was broadly sympathetic. Charles Kingsley, the novelist and clergyman, wrote to Darwin to say that it was just as noble a conception of deity to believe that he had created primal forms capable of self-development as to believe that he required a fresh act of intervention to supply the lacunas which he himself had made. Darwin liked this letter enough to quote it in later editions of The Origin. But other clergy were firmly opposed, and the question of how to reconcile the Genesis account of creation with Darwin's theory became a source of genuine conflict that would continue for generations. Into this atmosphere came the meeting at Oxford in June 1860, which has since acquired the status of legend to a degree that makes it somewhat difficult to assess clearly. The British Association for the Advancement of Science held its annual meeting at the Oxford University Museum of Natural History, and on the afternoon of June 30th, a session was scheduled to discuss papers related to Darwin's theory. The room was packed. Contemporary accounts suggest somewhere between 400 and 1,000 people were present, depending on who was telling the story and how long after the event they were telling it. Bishop Samuel Wilberforce was there. He was known as Soapy Sam, a nickname that referred to his smooth, polished speaking style rather than any particular cleanliness, and he was considered one of the most effective public speakers in England. He had been briefed by Owen and came prepared with a critique of Darwin's theory. Huxley was also there, though according to his own account he had not initially planned to speak at length. Joseph Hooker was present as well, and would later claim that his own contribution to the debate that afternoon was more significant than Huxley's, though Huxley's exchange with Wilberforce is the one that has survived in popular memory. The precise words of the exchange are not known with certainty. No transcript was made. The accounts that survive were written down months or years afterward, and they differ in their details. What the accounts broadly agree on is this. Wilberforce, at some point during his remarks, turned to Huxley and asked whether it was through his grandfather or his grandmother that he claimed descent from an ape. The exact phrasing varies between accounts. Some versions have it as a question about whether Huxley would prefer to be descended from an ape on his grandfather's side or his grandmother's side. The implication, in either version, was the same, that the theory of evolution was absurd because it placed human beings on the same family tree as animals, and that this was beneath the dignity of serious consideration. Huxley's reply, according to the most frequently cited account, written by his friend John Green in a letter shortly after the event, was something to the effect that he would not be ashamed to have a monkey for his ancestor, but he would be ashamed to be connected with a man who used his great gifts to obscure the truth. The exact wording again is disputed, but the spirit of it is consistent across most accounts. Huxley refused to accept the premise that descent from non-human ancestors was shameful, and he turned the insult back on the man who had made it, suggesting that intellectual dishonesty was a greater failing than any question of ancestry. The audience reaction, by most accounts, was dramatic. One woman reportedly fainted, though this detail may have been embellished. Several people cheered. The atmosphere was described as intense. Hooker spoke afterward and felt, by his own account, that he made the more substantive scientific case. addressing the botanical evidence for evolution more carefully than Huxley had. He was probably right about that, but it was Huxley's exchange with Wilberforce that people remembered and retold because it had the shape of a story, a clear challenge, a clear response, a winner and a loser. Science versus religion, or at least that was how it was often framed later, though the reality was considerably more tangled. Darwin was not there. He was at a hydropathic spa in Sudbrook Park, Surrey, undergoing a water cure for his chronic illness. He followed events through letters. Huxley wrote to him with a brief account. Hooker wrote a longer one. Darwin expressed gratitude and relief. He had known the Oxford meeting was coming and had known he would not be present. And the news that Huxley had handled the confrontation effectively was, for him, something close to a physical relief. The debate at Oxford did not settle anything in a scientific sense. It was a public performance, not a scientific argument, and its significance was more symbolic than empirical. But symbolically it mattered quite a lot. It established in the public imagination that Darwin's theory had defenders who were willing to stand up for it in the most visible possible forum against the most polished opposition the other side could produce. The theory was not going to be argued out of existence by clever rhetoric. That was the message, and it landed. Over the months and years that followed, this scientific conversation became more detailed and more technical. The questions that serious scientists raised about the origin were not about whether evolution had occurred, that part was increasingly accepted, but about the mechanism and the completeness of the evidence. The fossil record had gaps. Darwin acknowledged this honestly in the book, devoting an entire chapter to the imperfection of the geological record and explaining why he thought the gaps were expected rather than damaging to the theory. But critics pointed to the gaps anyway, and some of them pointed with genuine scientific seriousness rather than theological anxiety. The question of inheritance was the most significant unresolved problem. Darwin knew that variations existed. He could observe them in domestic animals, in wild populations, in the specimens he had collected across 5 years at sea. He knew that some variations were heritable, passed from parent to offspring, but he did not know how. He proposed a mechanism he called pangenesis, the idea that tiny particles called gemmules were shed by every cell in the body and collected in the reproductive organs, carrying information about the parent's characteristics to the next generation. This was wrong. His cousin Francis Galton tested it experimentally in the early 1870s by transfusing blood between rabbits of different coat colours, reasoning that if gemmules circulated in the blood, the offspring of the transfused rabbits should show mixed characteristics. They did not. Darwin defended his theory but could not explain the failure convincingly. The mechanism of inheritance remained a genuine gap in his argument, and it would remain a gap until the rediscovery of Mendel's work decades after Darwin's death. None of this slowed the broader acceptance of the core idea. By the mid-1860s, the reality of evolution, of descent with modification from common ancestors, was accepted by most working naturalists in Britain and increasingly in Europe and America. What remained contested was the relative importance of natural selection as the mechanism. Some naturalists accepted evolution, but believed that selection was only one of several forces shaping species. Others thought that evolution proceeded in jumps rather than gradually. These debates were real and substantive, and they continued long after Darwin's death. But the central claim that species were not fixed, that life had a history, that all living things were related by descent, had moved from radical proposition to scientific consensus within roughly a decade of the Origins publication. That is a remarkably short time for an idea that contradicted centuries of received understanding. Darwin followed all of this from Downhouse, reading the journals, corresponding with scientists around the world, revising successive editions of The Origin, and continuing his own research with the patient. Curious energy that had always been his most consistent characteristic. He was not a man who rested on a single achievement. The theory was out, the arguments were proceeding, and he had other things to look at. The orchids were interesting. The earthworms were interesting. The question of how emotions were expressed in animals was interesting. There was always something else to examine, measure, think about carefully and write down. The public arguments about the theory continued around him, sometimes involving him directly, sometimes not. He watched the debate spread to America, where Asa Gray defended him and Louis Agassiz opposed him. He watched it move into philosophy, into theology, into political thought. Though he was deeply uncomfortable with the ways his ideas were sometimes recruited to justify social hierarchies, a use of his theory he had not intended and did not endorse. He watched it become, in a way he had not fully anticipated, the kind of idea that did not stay inside science, that leaked out into everything else, that changed the way people thought about themselves and their place in the world. That was not something he had planned. He had set out to explain the distribution of species. He had come back from a voyage with notebooks full of observations and a head full of questions. The theory had emerged from those observations and questions over many years of careful thought. What it meant for humanity's understanding of itself, that was a consequence he had seen coming and had been afraid of and had eventually accepted as unavoidable. But it was not what he had been trying to do. He had been trying to understand why the mockingbirds on the Galapagos were different on different islands, and why the fossils in the Pampas looked like giant versions of living animals, and what that pattern meant. The rest had followed from that slowly, over a lifetime. And now, with the book in the world and the argument spreading and the science beginning to move forward on its own momentum, Darwin himself was still at his desk, still writing letters, still walking the sandwalk, still watching the earthworms turn over the soil in his garden, with the same attentive interest he had brought to everything since he was a young man collecting beetles at Cambridge. The theory had changed the world's understanding of life. Darwin's own daily life looked, from the outside, much as it always had, which was perhaps exactly right. The public confrontations would continue, the revisions would keep coming, the science would deepen in ways that neither Darwin nor anyone else in 1860 could have foreseen. But for now, the immediate aftermath of the origin had established something important. The idea was serious, it was defensible, it had supporters willing to argue for it publicly, and it was not going to disappear. What Darwin did with the rest of his life, the work that followed the theory, the quieter decades at Down House, the books that came after, and the long, slow accumulation of everything the voyage had set in motion, is where the story turns next. Down House was not a dramatic place. It was a large, comfortable, somewhat plain country house in the village of Down in Kent, about 16 miles south of London. Darwin moved there with Emma in 1842, 11 years after he had first boarded the Beagle as a young man who had never been further than Wales. He would spend the remaining 40 years of his life there, and he would almost never leave. This is worth pausing on for a moment. The man who had ridden on horseback across the Pampas, who had climbed the Andes on a mule, who had watched a city collapse in an earthquake, who had sailed around the world and collected specimens on 4 continents, that man spent the second half of his life in a garden in Kent, rarely travelling further than London, and sometimes not even that far. He was not a recluse exactly, but he was something close to it, and for most of those years his body gave him very little choice. The illness that settled over Darwin after the voyage has been debated by doctors and historians for well over a century. He suffered from nausea that came in waves, sometimes severe enough to prevent him from working for days at a time. He had heart palpitations, trembling hands, fatigue that could flatten him without warning, and a persistent eczema-like skin condition. He vomited frequently, often in the mornings, and found that social engagements, dinners, meetings, visits, would leave him exhausted and sick for days afterward. He tried many treatments over the years, including a water cure at a hydropathic establishment in Malvern, where he spent weeks being wrapped in cold wet sheets and doused with cold water, which he reported helped him temporarily. He tried other cures, other doctors, other regimens. None of them solved the underlying problem because no one could agree on what the underlying problem was. One theory that gained traction in the 20th century is that Darwin contracted Chagas disease, caused by the parasite Trypanosoma cruzi, transmitted by the bite of a triatomine bug. He recorded in his diary that on March 25, 1835, in the village of Luxon in Argentina, he was attacked at night by what he called the great black bug of the pampas, a benchuca, which is a local name for the triatomine. He described it as disgusting, and noted that it fed on him for 10 minutes before he removed it. Chagas disease can remain dormant for years, and then produce chronic cardiac and gastrointestinal symptoms that match Darwin's complaints remarkably well. The theory is plausible, though not proven. Other researchers have proposed anxiety disorder, cyclic vomiting syndrome, or the cumulative effect of the seasickness he suffered throughout the voyage. Some have suggested his illness was at least partly psychosomatic, triggered by the stress of holding an idea he knew would be controversial and the fear of his father's disapproval, which lingered even after Robert Darwin died in 1848. The honest answer is that nobody knows for certain. What is certain is that the illness was real, persistent, and limiting, and that Darwin worked within it and around it for his entire adult life with a patience that is quietly remarkable. His day at Down House was structured carefully to protect his working hours. He rose early, took a short walk before breakfast, worked in his study from about 8 to 9:30 in the morning, then read his letters, then worked again from 10:30 until noon. After lunch he walked his thinking path, the sand walk, a gravel loop he had laid out at the edge of his property through a small wood. He would walk it multiple times, sometimes placing flints at the start so he could count his circuits. He rested in the afternoon, read, wrote letters, and did another short spell of work in the early evening. Then he read aloud with Emma, or listened to her play the piano. He was in bed early. This was, with variations, the shape of almost every day for 4 decades. Within that routine, he produced an extraordinary amount of work. The origin of species was not the end of his scientific output. It was, in some ways, the beginning of a second phase. In 1862, he published On the Various Contrivances by which British and foreign orchids are fertilised by insects, a detailed study of the relationship between orchid flowers and the insects that pollinate them. It sounds modest. It was not. Darwin used orchids to demonstrate natural selection in action, showing how the intricate structures of flowers were not the product of design for beauty's sake, but of a long functional relationship between plant and pollinator. He had a greenhouse at Down House where he grew orchids and observed them directly, and the book is full of the kind of specific patient observation that had been his habit since the Beagle. The Descent of Man came in 1871, and this one was harder to write and harder to publish. Darwin had deliberately avoided the subject of human evolution in the origin, mentioning it only in a single careful sentence near the end. He knew the question would come, and he let it come on its own terms for 12 years before addressing it directly. The Descent of Man argued that human beings were descended from earlier primate ancestors, that the difference between humans and other animals was one of degree rather than kind, and that human mental and moral faculties had evolved through natural selection just as physical characteristics had. The book also discussed sexual selection, the idea that mate choice could drive evolutionary change independently of survival pressure, which Darwin had been developing for years, and which explained things like the peacock's tail that pure survival of the fittest logic struggled to account for. The reaction to the Descent of Man was significant, though perhaps not quite as explosive as the origin had been. By 1871, the idea of evolution was already widely accepted in scientific circles, and many people had already drawn the human implications themselves. Still, seeing it stated plainly, with evidence, in Darwin's own hand, was a different thing from inferring it. The book sold well and generated debate, and Darwin followed the responses with his usual mixture of anxiety and careful attention. A year later, in 1872, he published The Expression of the Emotions in Man and Animals, a study of how emotional states are expressed through facial expressions, posture, and behaviour, and how these expressions are shared across species and across human cultures. Darwin had been collecting data for this book for years, corresponding with missionaries, doctors and travellers around the world, and asking them specific questions about how people in different cultures expressed grief, anger, surprise and fear. He also used early photographs, some taken by the neurologist Guillaume Benjamin Duchenne, who had used electrical stimulation to produce expressions in human subjects to illustrate his arguments. The book was one of the earliest scientific studies of emotion, and its central claim that emotional expression has an evolutionary history shared across species is now foundational in psychology and neuroscience. He also published detailed studies of insectivorous plants, climbing plants, and the formation of vegetable mould through the action of earthworms. The Earthworm book, published in 1881, the year before he died, was the last book he completed. It documented how earthworms, through their constant burrowing and casting, slowly turn over the soil and bury objects left on the surface. Darwin had been observing earthworms in his garden for decades, placing stones on the lawn and measuring how deeply they sank over the years. He estimated that in a field, earthworms might bring between 10 and 18 tons of dry earth per acre to the surface each year. The book sold remarkably well, better than he expected, and it made a quiet but important point, that enormous changes could accumulate through the slow, patient action of small forces over long periods of time, which was, in a sense, the same point he had been making since the origin. Through all of this, Emma was there. Emma Wedgwood had married Darwin in January 1839, before the theory was published, before Down House, before most of the work that would make his name. She was intelligent, kind, and deeply religious, and she worried about what Darwin's conclusions meant for his soul. She had written him a letter early in their marriage expressing her fear that his habit of doubting everything might lead him away from faith, and that they might not be together in whatever came after this life. Darwin kept the letter always. He wrote a note at the bottom of it. "When I am dead, know that many times I've kissed and cried over this." They had 10 children together, and the grief of losing 2 of them, Mary Eleanor, who died in infancy in 1842, and Anne, who died in 1851 at the age of 10, marked both of them deeply. Anne's death in particular seems to have been a turning point for Darwin, after which his remaining religious faith, already fragile, largely dissolved. He described himself in later life as agnostic, a word that had only recently been coined by his friend Thomas Henry Huxley. Emma never stopped worrying, and Darwin never stopped being gentle about it. They disagreed on the most fundamental question either of them could imagine, and they loved each other with great steadiness for 43 years. There is something in that which resists easy summary. It was simply the texture of their life together. Darwin died on April 19th, 1882 at Down House. He was 73 years old. In his final days he had heart attacks, and at the end he said to Emma and the family gathered around him that he was not the least afraid of death. He was buried in Westminster Abbey, near the grave of Isaac Newton, after a campaign by Huxley and other scientific colleagues who felt that the Church's willingness to honour Darwin was itself a kind of statement about where things stood. Fitzroy was not there to see it. Robert Fitzroy had died 17 years earlier, in April 1865, by suicide. The same manner of death as the uncle whose fate had worried his friends throughout the Beagle voyage. Fitzroy had spent his later years as Vice Admiral, as the founder of what would become the UK Met Office, and as a man increasingly tormented by the role he had played in bringing Darwin to the places that had produced the theory he believed contradicted Scripture. He had attended the Oxford debate in 1860, and had stood up in the audience holding a Bible, urging the crowd to trust the word of God over the word of men. Nobody remembered him for that. They remembered him for the voyage. There is something genuinely sad in Fitzroy's story that is easy to overlook when the history focuses, as it usually does, on Darwin alone. Fitzroy was a brilliant man, a skilled navigator, a gifted meteorologist, a careful scientist in his own right. He had commanded the Beagle with competence and dedication across 5 difficult years. He had invited Darwin on the voyage. Without that invitation, made partly because Fitzroy was lonely and wanted a dinner companion, the theory of evolution by natural selection might have arrived decades later, or through entirely different hands. Fitzroy shaped the voyage, and the voyage shaped the theory, and the theory became the thing that haunted him. History can be unkind in that particular way. Darwin's work did not stop being relevant when he died. If anything, the decades after his death saw it confirmed and extended in ways he could not have imagined. The rediscovery of Gregor Mendel's work on inheritance in 1900 provided the mechanism Darwin had been missing, the particulate inheritance through discrete units that we now call genes. The modern evolutionary synthesis of the 1930s and 1940s united Darwinian natural selection with Mendelian genetics into a single coherent framework. The discovery of the structure of DNA in 1953 by Watson, Crick, Franklin, and Wilkins revealed the molecular basis of inheritance, and the development of molecular biology and genomics in the decades that followed confirmed the core of Darwin's argument at a level of detail he could never have anticipated. When scientists sequenced the human genome in 2003, they found within it the accumulated history of evolution written in 4 chemical letters, exactly the kind of evidence that Darwin had argued must exist, though he had no way to see it. The voyage of the HMS Beagle was 5 years long. Darwin was seasick for most of them. He collected thousands of specimens, filled dozens of notebooks, and came home a different person than the one who had left. The theory that eventually emerged from those 5 years took another 20 to develop, another 20 to be accepted, and has been expanding and deepening ever since. What the voyage gave Darwin was not the theory itself. It gave him the questions, and it gave him the habit of looking carefully at the world and trusting what he saw, even when what he saw was uncomfortable, even when it pointed somewhere he had not expected to go. That habit, more than any single discovery, is perhaps what the Beagle voyage most durably produced. And what it means now, for science, for how we understand life, and for what it tells us about the slow, patient nature of understanding itself, is where this story finally comes to rest. The voyage of the HMS Beagle lasted 1,741 days. That is a number worth sitting with for a moment. Not because it sounds large. It is roughly 4 years and 9 months, which is long but not incomprehensible, but because of what was happening inside those days. Darwin was seasick for most of them. Not occasionally, not during rough patches, but chronically, persistently, miserably seasick, in a way that never fully resolved itself across the entire journey. He described it in letters as a torment. He lay in his hammock above the chart table in his tiny poop cabin and suffered, and then, when the ship anchored or he could get ashore, he went out and collected beetles and lizards and shells and fossils with extraordinary energy, as if the land itself was medicine. Which for him, perhaps it was. He collected roughly 5,436 animal skins, bones and fossils, 3,907 geological specimens, 1,529 species preserved in spirits. He filled 15 notebooks. He sent back 1,750 pages of notes to Henslow in Cambridge, who read them aloud to the Cambridge Philosophical Society, and told anyone who would listen that his former student was doing something remarkable. All of this from a young man who had been sent to sea partly because his father thought he needed direction, and who had nearly been turned away by the captain because of the shape of his nose. What is striking, when you look at those numbers, is not their size but their texture. Every specimen had to be caught, killed, preserved, labelled, packed and shipped. Every geological note had to be written in the field, often on horseback or on a cliff face or in a forest so dense Darwin could barely move through it. The work was physical and slow and patient, and it required a particular kind of attention, the kind that does not look for the dramatic conclusion first, but instead watches, records, and waits. Darwin developed that attention on the Beagle, and he never lost it. It was the quality that made him, in the end, a great scientist. Not brilliance in the lightning bolt sense. Patience. Careful, methodical, almost stubborn patience. The theory that came from the voyage did not arrive during the voyage. That is one of the most important things to understand about how it all worked. Darwin was in the Galapagos for 5 weeks, and he did not understand what the finches meant while he was standing among them. He ate the tortoises, he mislabeled the birds, he noticed interesting things but did not yet know what they were interesting for. The meaning came later, in a room in London in January 1837, when John Gould laid out the birds and told him they were all finches. The voyage gave Darwin the raw material. The thinking came after, slowly, in fits and starts, across years of illness and barnacle studies and quiet walks on the sand walk at Down House. The Beagle did not produce the theory of evolution. It produced the man who would eventually produce the theory, and it gave him the questions he would spend the rest of his life trying to answer. That distinction matters, because there is a tendency in how we tell the story of scientific discovery to compress the timeline, to make the insight seem more sudden and more located than it actually was. We say Darwin went to the Galapagos and discovered evolution, and that sentence is wrong in almost every way. He went to the Galapagos and noticed some things. He went to Patagonia and dug up some bones. He went to the Andes and found marine shells at 13,000 feet. He went to Concepcion and watched the ground rise. None of these moments were the discovery. They were the accumulation. And the accumulation only became something when Darwin sat with it long enough, read the right book at the right moment, talked to the right ornithologist, and allowed himself to follow the logic wherever it led, even when it led somewhere uncomfortable. He called the idea, early on, like confessing a murder. That phrase has always seemed to me one of the most honest things any scientist has ever said about their own work. He knew what he had. He knew what it meant. He knew how the world would receive it. And he sat with that knowledge for 20 years before the letter from Wallace arrived and forced his hand. 20 years of knowing and waiting and accumulating evidence and studying barnacles and writing letters and walking the sand walk and not quite being ready to say it out loud to the world. That is not cowardice. That is a very human kind of caution, the kind that comes from understanding the weight of what you're about to put into the world. When On the Origin of Species was finally published on November the 24th, 1859, the first edition of 1,250 copies sold out on the day of publication. The world had been waiting, even if it had not known it was waiting. The reaction was immediate and divided and passionate, and sometimes cruel and sometimes generous, and mostly exactly what Darwin had expected. He followed it from Down House, through letters, too ill to attend the debates himself. He revised the book through 6 editions, adding evidence, responding to critics, adjusting his language, never retreating from the central argument. He was not a man who enjoyed confrontation, but he was not a man who abandoned a position he believed in either. He had learned, on the Beagle, to trust what he observed. He kept trusting it. The theory of evolution by natural selection is now the organising framework of all modern biology. Every field that touches living things, medicine, ecology, genetics, paleontology, immunology, agriculture, epidemiology, rests on it in some way. When doctors try to understand why bacteria develop resistance to antibiotics, they are applying Darwin's logic. When conservation biologists try to understand how populations respond to habitat loss, they're applying Darwin's logic. When scientists sequence the genome of a newly discovered species and trace its relationships to other species through shared DNA, they're applying Darwin's logic. The discovery of the structure of DNA in 1953 and the development of molecular biology in the decades that followed did not challenge Darwin's framework. They confirmed it at a level of molecular detail he could never have imagined and would probably have found deeply satisfying. The human genome, sequenced in 2003, is in one sense a record of everything that has ever happened to our lineage, written in 4 chemical letters going back to the beginning of life on Earth. Darwin predicted something like it must exist. He just could not see it. None of that came from a sudden flash of genius on a volcanic island in the Pacific. It came from 5 years of careful, miserable, extraordinary fieldwork, followed by 20 years of quiet, patient thinking in a house in Kent, followed by a lifetime of scientific work that never really stopped. Darwin published books on orchids, on climbing plants, on insectivorous plants, on earthworms, on the expression of emotions in animals. He kept looking at the world with the same patient curiosity he had developed on the Beagle, right up until near the end. The Voyage did not give him the answers. It gave him the habit of asking. There is something in that worth carrying with you, whatever you are doing, wherever you are listening from tonight. Understanding, real understanding, the kind that changes how you see things, rarely arrives complete. It arrives in pieces, collected over time from places you did not always expect. It arrives as a fossil in a cliff face in Patagonia that looks like a giant armadillo. It arrives as a bird in a drawer in London that turns out to be a finch. It arrives as a land that rises 10 feet in 2 minutes during an earthquake in Chile. And suddenly Lyell's slow geology is not a theory anymore, but something you felt in your body. The pieces accumulate, the pattern emerges, and then, eventually, if you are patient enough and honest enough to follow where it leads, the understanding comes. Darwin was not a perfect man. He was anxious, often ill, sometimes slow to give others the credit they deserved. He benefited from wealth and social position that most naturalists of his era did not have. His relationship with Wallace was complicated, and historians still debate whether the joint announcement at the Linnean Society was entirely fair to Wallace, who had arrived at the same idea independently and deserved more recognition than history initially gave him. Darwin's later writings on human races reflected assumptions that were common in his time and are rightly criticised today. He was a man of his era in ways that matter, and the full picture of who he was is more complicated than the icon on the £10 note. But the voyage was real, the work was real, the theory was real, and it was hard won, and it changed everything. A wooden ship, 90 feet long, carrying 74 people across 5 years and 40,000 miles of ocean, carrying one young man who was seasick almost the entire time, and who collected beetles obsessively and argued with his captain about slavery and found marine fossils in the Andes and did not quite understand what the finches meant until he was sitting in London talking to an ornithologist. That voyage produced the most consequential idea in the history of biology. Not because the voyage was a scientific expedition in the planned, funded, institutional sense. It was a hydrographic survey. Darwin was there to keep the captain company at dinner. The science happened because one curious, patient, careful person paid attention to what he saw and trusted the questions it raised, even when the questions were inconvenient and the answers were years away. The Beagle herself was sold out of naval service in 1870 and broken up. There is no monument to her. The exact site of her final mooring in the River Roach in Essex was only identified by researchers in 2004, buried in the riverbed mud. Fitzroy's name is mostly remembered now in weather forecasts. The sea area Fitzroy in the North Atlantic shipping forecast was renamed in his honour in 2002, replacing the old name Finisterre. It is a quiet kind of memorial for a complicated man who deserved better than the torment his later years brought him. And Darwin rests in Westminster Abbey near Newton, in a building that represents the very institution whose worldview his work had done so much to complicate. There is a gentle irony in that, or perhaps not irony at all. Perhaps just the usual way that history absorbs even its most disruptive ideas, and makes them, eventually, part of the furniture. If you have followed this story all the way from Plymouth Harbour in December 1831, through the rainforests of Brazil and the fossils of Patagonia, and the cold winds of Tierra del Fuego, and the black volcanic shores of the Galapagos, and the coral atolls of the Pacific, and the long years at Down House, and the debates, and the revisions, and the quiet death in Kent, thank you for staying with it. It is a long story. It deserved to be told slowly. The world is full of journeys that look small from the outside. A wooden ship, a young man, 5 years at sea, and inside them sometimes, something that changes everything. Sleep well wherever you are tonight. The questions are still out there, waiting for someone patient enough to follow them.